Hey NEET warriors, long time no see. How are you all doing? Welcome aboard to the Vedantu NEET English channel. And this is your one and only Captain Shreyas, your physics master teacher. And we are on our target of completing our 2000 plus questions live in this NCERT line by line session of all the 4 subjects: physics, chemistry, botany and zoology, from your favorite master teachers Diksha ma'am, Baswa sir, Gopika ma'am, and of course your captain. Let's light it up. Thank you Sanvi, hello Yuvraj, hello Sensei, my buds. Wow, what a nice name. Hello Krishna, hello Sunlight. Wow, you have some amazing names. Yeah, you guys are very creative. Very nice to see all of you. I hope I'm audible and visible too. Nice to see all of you out here. And how is your preparation going? How did you like the previous session? Just let me know in the comments as well after the session ends, okay? And if you're watching it recorded too, I would love to know more about you. I would love to hear how you are enjoying these sessions in the comments down there, okay? Because obviously when you crack NEET and when you meet me and when you meet the entire team, I would definitely remember your name and oh, you are that student who used to watch my sessions and used to always comment, and now here you are to become a doctor. So yes, put it up, because that is the power of, manifestation. So when you manifest something and when you always push yourself positively, even though you do not believe in it, but trust me, the universe will work towards making your goal into reality. So let's begin with the class. I'm going to detail out all the NCERT lines, which are very, very crucial, not just from your NEET perspective, but obviously your board's perspective as well. So both kinds of students can join, either a 12th student or a dropper student. And if you are a legend or an ultra legend in 9th, 10th or 11th standard, you can still watch this class, although this chapter is in class 12th, right? The magnetic effects of current and magnetism. So if you're all geared up for this, smash the like button right now. Hello Priyadarshini, hello, good evening Gani, hello Bharti, hello NEET 2024, Ashi, welcome, hello Sejal, hello Sensei. Nice to see all of you. Ready for the filling the blanks? Starting off with physics, then you are going to have biology, and then you're going to have chemistry. Don't miss any of the classes. Here comes the first question on your screen. The magnetic field. By the way, you have to spam the answers in the chat box. Even if it is wrong, it's okay. At least copy from others and write it. Even that effort, if you are taking, no, I am very happy. It will subconsciously register in your head. Don't think, sir, I didn't answer, I was copying from other person. It's okay, man. At least you are typing, at least you are doing that effort. No, it will register in your head. Okay. So what is the answer for this particular question? The magnetic field lines around a current carrying conductor is visualized by dashed lines. So whenever, oh, where is my pen? Yes, the correct answer for this is magnetic lines, because what happens whenever you have a current carrying coil? If this is a current carrying coil, then the magnetic field lines are like this. So you visualize it. You are visualizing it through the magnetic field lines when a current passes through any conductor, right? So obviously not electric field lines. That was a simple one. Moving on to the next one. Whatever lines I am giving here, either this can be a blank or this can be a blank. You can play around with the question, okay? There is nothing like, okay, only this blank can come, and just you can play around with it. Okay, moving on. The direction of the magnetic field produced by a straight current carrying wire can be determined using the dash rule. What is that rule? Interesting. Everybody should know this. How do you predict the direction of the magnetic field which is produced by a straight wire which is carrying some current? So what is that rule, my dear warriors? Come on. If there is a straight wire which is carrying current and you want to predict the direction of the magnetic field, what do? You curl your fingers, right? You curl your fingers and your thumb will point in the direction of the current. So that is basically your right hand thumb rule. Right hand thumb rule. Very good. No, not left, Sai Divya. It is the right hand thumb rule. Okay, no problems. Even if you made a mistake, it's perfectly okay. At least now, in the next time in the exam, you will use your right hand and not the left hand. That is the main purpose of this, right? Okay, next question. The SI unit of magnetic field strength or magnetic induction, or just the field due to magnetic poles or field due to bar magnet, what do you think it is? Come on, put up the answers in the chat box right now. Everybody put up the answers in the chat box right away right now. Yes, what is it? It is Tesla. Tesla also reminds you of the Tesla car by Elon Musk. So Elon Musk, magnetic field. That's how you can remember it. By the way, you should also know the other units of magnetic field. How many of you know Gauss? How many of you know Gauss? One Gauss is how many Teslas? One Gauss is 10 to the power minus 4 Tesla. Keep this in mind. This is also another unit of magnetic field. Keep this in mind. Okay. Chalo, let's move on to the next one coming up on your screen. The force experienced by a current carrying conductor placed in a magnetic field is given by F is equal to something where I is the current, L is the length, B is the magnetic field strength, theta is the angle between them, then F is measured in watt. So filling the blanks, 2 answers will pop up in the chat box. Start spamming in it. How much is the force on a wire which carries current? Force on a wire which carries current. Come on, this is very straightforward. Let's see how many of you can get this. Force on a wire which is carrying some current is given by IL cross B. Cross product means sine, so it should be ILB sine theta, and the force obviously is measured in newtons, right? The actual way, where did it go? Yeah, the actual way you write the force is I length cross product with B. So your wire might be like this. It is carrying some current. This is the length. So this is the length vector. Your B vector might be like this. You do L cross B. First put it in L, then in B. Your thumb is the direction of that force. Your thumb is the direction of the force. That's how it works, right? Sure. Let's move on to the next one. The magnetic field at the center of a loop carrying current is given by this, where R is the radius, mu naught is known as what, and what is the value of it? Come on, put up the answers in the chat box right away right now. Right away right now. This is the standard formula, my dear warriors. This is the standard formula. Whenever you have a loop which carries some current, then you will see that there is some magnetic field at the center. That magnetic field has this particular formula, mu naught current divided by 2R. The value of mu naught, you should know this, 4 pi into 10 to the power minus 7. 4 pi 10 to the power minus 7. Very good. No, not just 10 to the power minus 7. Many people miss that 10 to the power, 4 pi. So it is called as the permeability of free space. Permeability of free space. Everybody with me? Very good, very good. Keep it up, keep it up. Keep up the answers running and share this session with your friends as well, because this session is going to be a rank booster. It's going to, help you not just revise but also help you in your board's examination. So it will help you revise for your NEET as well as board examinations. Cool. So let's move on. The phenomena by which a material temporarily becomes a magnet when it is placed in some external field. You take something, you place it in some external field. For some time, temporarily, it behaves like a magnet. What is that property called as? What is that property called as, my dear warriors? Come on. What is that property called as? What is that property called as? The phenomena, it becomes temporarily a magnet when it is placed in an external magnetic field. That is called as, that material is called as paramagnetic, or yes, but that phenomena by which it gets magnetized, the phenomena by which it gets magnetized, that is called as magnetization. You're magnetizing it. No, it's not called ion, it's not called solenoid, no, it's not called magnetic induction, it is called I am magnetizing it. So magnetization. The magnetization is the phenomena by which some material, you take wood, you take iron, doesn't matter. If it is getting magnetized, so that phenomena is called magnetization. That material is called paramagnetic because it is temporarily magnetized. It could be diamagnetic also. but it is not going to be a ferromagnetic, because ferromagnetic materials are permanently magnetized. Keep that in mind. So understand, material is para, dia, ferro, but the property, the phenomena is magnetization. Okay. Earth's magnetism is caused by currents flowing in the where. Although Earth's magnetism is deleted, still I am doing this because you might get a question on this. You might get some boundary level questions. Let me tell you, don't completely ignore the deleted syllabus. Sometimes they might push the limits, and you will see that I'll be making a separate video also on this, on how, you know, in the JEE mains there were some boundary level questions, and many students were, you know, clean bold thinking, oh my god, what is this? I never thought that this type of question might come, but actually ended up coming. All right. So the correct answer is Earth's core. Exactly. At the Earth's core. At the Earth's core. Where is that Earth? Come on, man, Earth. Yeah, blue color Earth. We'll draw. There is hot lava. That hot lava is there. That hot lava is rotating. So that lava has charges. It's like current. It's like current loops. So that current loop is what creates that magnetic field. That is what creates that magnetic field. Okay, that is how you can visualize it at the Earth's core. Okay, not the Earth's crust, it's the Earth's core. Core is the center, crust is the outer periphery, the circumference of the Earth. That is the crust of the Earth. Okay. The galvanometer can be converted into ammeter by connecting a dash resistor. What is that resistor's name? What is that resistor's name called as? What is that resistor's name called as? Come on, my dear warriors. Let me know the answer in the chat box. Let me know the answer in the chat box. What is the answer? Yes, it is called as the shunt resistance. Shunt means parallel. Sometimes they might give you a question, to make a galvanometer into ammeter, a resistor has to be connected in series or in parallel. Then the answer will be parallel. So that filling the blank can also be a part of your NEET examination. And not just that, sometimes they can also tell you the resistance of an ammeter is how much. Is it large or is it very low? The answer is it is very, very low. So the reason for that is because you take a very small resistance and connect it in parallel. So as a whole, when it behaves like an ammeter, it will have very little resistance. When you connect resistors in parallel, the final resistance is smaller than each of these resistors. That's why the ammeter has a very, very low resistance value, because of these parallel or shunt resistances. Very good. Keep it up, my dear students. Awesome, Shiva. Very good, Raj. Very good, Jamal. Very good, Jamana. Krishna. Very good, Sai Divya. Very good, Subiksha. Awesomeness. The magnetic flux through a surface placed in uniform field is given by dash. Theta is the angle between B and normal. Phi is measured in which unit? Think about it. Phi is representing magnetic flux. The flux through an area. You take an area, field lines pass through it. That is called as magnetic flux. Flux means flow. Magnetic flux means flow of the magnetic field. That's all. So you have some area, you have some field, it is making some angle. What is the formula? It is a dot product. Remember that. So dot means cos and flux is measured in Weber. WB. Yes, BA cos theta. You can see that right over here. Flux is technically B vector dot A vector. And this unit is Weber. So 1 Weber is 1 Tesla into 1 meter square. Into 1 meter square. Is that right, everyone? Yes, very good, very good, very good. Yes, BDS, BA, whatever you want to use, definitely. Kudos. Moving on. Next question on your screen. The process of generating electromotive force in a conductor by changing the flux linked with it. What is that property, that phenomena called, the process called? When you generate electromotive force in a conductor by changing the flux, that means you're changing the magnetic field around it. You're changing it and you're creating EMF. meaning like a battery, with it is known as, what is that property called as? Come on, my dear warriors. Some of you are saying AC. No, is it AC? There is a chapter name only. The chapter name only is called as electromagnetic induction. Yes, it is called as electromagnetic. Yes, it is called as just induction. You are inducing electricity, induced current, induced EMF, electromagnetic induction, all these things. So depending on the options, obviously you are going to get options. Don't be scared. Sir, will I not get options? Obviously you will get options, right? Moving on to the next one on your screen. The law which states induced EMF in a loop is equal to the negative rate of change of something through the loop is known as something law. So to filling the blanks, who are those amazing NEET students or CBSE students who are going to answer this NCERT question filling the blank? Come on, my dear students, think about it. What do you think is the correct answer which will fill up these blanks? The law which will tell you about the induced EMF inside a loop is the negative rate, that means the derivative of something, some flux is there, is known as something law. I mean, this is the direct law of Faraday, Faraday-Lenz's law. That's what tells you that it is a rate of change of what? Magnetic flux. So if you remember Faraday's law, what was it? The EMF is minus d phi by dt. d phi by dt. Very good. Exactly. Kirtivasan, Anamika. Very good. Sai Divya. Farad law. Yes, Sensei. Farad. Short form of Faraday. Yes, there you go. The force between two parallel current carrying wires is attractive if the currents are in which direction? Same or opposite? If you answer this, very good. If you don't answer this, remember, always this confusion happens. So you better think of a way to remember this, attraction and repulsion. So what do you think is the correct, filling the blank over here? Whether they should be in the same direction or whether they should be in the opposite direction. So let me tell you, my dear warriors, you can have two situations. One when the currents are in the same direction, and the other one when the currents are in the opposite direction. Great. Now, if the currents are in the same direction, then what happens is they don't repel, in fact they attract. If they are in the opposite direction, then is when they will repel. It's exactly opposite like electricity. What will positive do or negative do? Repel, right? So here positive same will not repel, it will attract. It's opposite of electricity. Similarly, what does a positive charge say to the negative charge? Come close to me, I will attract you. But here one current, here another current, opposite currents, they will not attract, they will repel. So it's opposite to that of electrostatics. That's how you are going to remember it. Okay, I hope this is very, very clear, my dear students. Excellent. Everybody said, sir, same. Now whether you are saying, sir, my answer is same as the person above, or was it actually same? You will tell me. Yes, sir, same answer as above. Very good. The magnetic field around a bar magnet beginning at the dash pole and ends at the dash pole. The magnetic field around the magnet. So the question's answers will change if it said inside the magnet. So here the main word is around the magnet. So be very careful. So around the magnet, the magnetic fields begin at dash pole and end at the dash pole. So be very, very careful. Yes. How many of you have given the correct answer? Awesome. North pole to the south pole. So my dear students, for this particular question, if this is your north pole, this is your south pole, the magnetic field lines go like this and come like this. This is how they move from north to the south. But if it was inside, this word was not around, but it was inside a bar magnet, then it continues from south to north. It is a closed loop, remember that? It is a closed loop. It goes from south to north and north to south, south to north and north to south. This is how it circulates, it's a closed loop. Understood? Everyone, shall we go ahead to the next one? Yes, as you are watching this session, subscribe to the channel. Do not miss any notifications and updates. Lot of surprises, lot of amazing things coming up in the days, before the boards as well as the NEET exam. So make sure you are subscribed to the channel without a miss and click all notifications, or else you will miss the notifications, right? A coil of wire that produces a field when carrying a current is called a coil of wire that produces magnetic field while carrying a current. What is it called? What is it called that carries current and produces magnetic field? Well, there can be many names which you can think of, but one such name, many things can fill in the blank. Many things can fill in the blank, but one such name which will fill in the blank aptly is, when you have, actually the word should have been coils, not coil, coils of wire that produce a magnetic field. It is solenoid. So it should have been, technically there should have been there should have been coils of current, because there are many turns, and this is a solenoid. Current goes in and current comes out, and you will see that there will be magnetic field produced inside of it. Magnetic field which is produced inside of this solenoid. Very good. The unit of the magnetic flux. Come on, my dear students, I just told you. What is the unit of magnetic flux? What is the unit of magnetic flux? Let's see how many of you are attentive. Yes. Who is it? Who is it? It's like the Spider-Man. What does Spider-Man have? The power of creating webs, right? So Weber. So remember, magnetic flux, Spider-Man, right? So Weber, WB. 1 Weber is 1 Tesla into 1 meter square. 1 Tesla into 1 meter square is 1 Weber. Strength of the field produced by solenoid is directly proportional to the dash of the turns per unit length and the current. Actually, we could have made more fill in the blanks out of here. We could have made definitely more fill in the blanks. So what is the formula? If you remember the formula, that's it. The magnetic field due to a solenoid is mu naught Ni. What is this N? It is number of turns per unit length. Number of turns per unit length. It is also proportional to the current. So both the things are there, number of turns and the current as well. That is the formula. Exactly. Now remember one thing, there have been questions in NEET where they had asked something like this. You have a solenoid, you have a long solenoid like this. Inside we know the magnetic field is mu naught Ni. But when you reach the end, the field lines are slightly away. So at the end, what is the field? It is mu naught Ni by 2. It's half. It's basically half. It's half of this. It's half of this, which is at the end. Keep this in mind, right? Towards the end, it is less. Inside, almost throughout the length, it is almost mu naught Ni, which is almost uniform. Magnetic field exerts no force on a charged particle when the particle moves dash to the field lines. Come on, this is straightforward. This is straightforward. Let's see how many of you can do this. The magnetic field will exert no force when the charged particle goes parallel or even anti-parallel. Yes, perfect. So see, my dear students, what happens is the formula that you need to make use of is F is equal to QV cross B. QV cross B. So if velocity and magnetic field are parallel, then the cross product which you have, will become 0, because V cross B is VB sine theta. Theta is 0 because V and B are parallel. It is also possible that velocity and magnetic field are anti-parallel, then also sine theta will be 0. So understand, in both these cases, sine 0 is 0, sine 180 is 0. So technically parallel or anti-parallel both will work. Parallel or anti-parallel, both options will work. Awesome. Awesome. Let's move to the next question coming up on your screen. Materials that are strongly attracted to a magnet and can be permanently magnetized are called as what kind of materials? This is more like, chemistry question also. And this is also general knowledge question. You should know about it. Come on. And by the way, I would also love to know if you want a very special NCERT kind of marathon just like this, but maybe in a very different way. Something really special. And do you want all these marathons clubbed together, you know, every day? What say? Do you want to take it up as a challenge very soon so that we finish the entire 12th portion in just a matter of few days? What say? And if you want it, then please leave it in the comments after the video ends. Also share this video and get many more students to the channel. Then if you show that response, if you show that support, and if you like each other's comments, yes sir, we want to complete the entire 12th standard portion in just few days, let's take it up as a challenge, then we will do it for all of you. It's going to be really painful for us doing this every day, but it's little bit easy for you. So we are ready to step in and we are ready to take in that hard work if you show that love and support. Okay, let me know in the comments after that. Yes, it is ferromagnetic. So ferromagnetic materials, iron, cobalt, nickel, these materials, once they are inside a magnetic field, they get magnetized permanently. And even if that outside field goes off, no, they will still behave like teeny mini magnets. Yep, right? Very good, ferromagnetic. And I can see a lot of students up for the game. And let's keep on smashing the like button down there as we proceed. If you have forgotten, give your Guru Dakshina right now. Oh, I by mistakenly showed off the filling the blank, but it's okay. The tendency of a coil to oppose the change of electric current passing through it, creating induced field, is called as, is described by what? Is described by what? Think about it. If you have a coil which opposes any kind of change in the current passing through it and it creates an induced field, then that property is called as, the tendency is called as what? Inductance. Exactly. It is called as inductance. Very good, my dear students. So what happens in an inductor is that if this is a coil and you pass some current, the tendency of a coil to oppose any change of current. So if the current, let's say it changes by some delta value, so you will see immediately it will oppose by creating a new induced field, and it will definitely, you know, not like any kind of changes in the current. So it will create an induced field which will oppose the change of the current. That property is called inductance. Inductance is also called electrical inertia. Electrical inertia, write it down in your notes wherever you are written inductance. Electrical inertia, resistance to change. Inertia means I don't like to change, I am okay however I am. So that is electrical wise inertia. It does not like to change the current. Magnetic field inside a long solenoid carrying current is, we know the formula, but is there some property also? Yes, definitely. The magnetic field is uniform and it is also mu naught Ni, just like I told you. So inside that solenoid, remember, inside that solenoid, you will see the magnetic field lines are almost uniform, parallel to each other. So it is uniform. Keep this in mind. Ratio of the magnetic flux to the current in a circuit is known as the circuit's what? Is known as the circuit's what, my dear warriors? Come on, think about it. Is known as the circuit's what? The ratio of the magnetic flux, to the current in a circuit. This is a standard formula. Divide flux, divide current, divide flux with current. See what you get. You will get only one thing, and that is the inductor's property, which is inductance. Remember, this is the formula. In fact, this was a formula. Phi is equal to Li. So phi by I is L. Exactly what has been asked in this particular question. So my dear students, the answer was inductance. Is that right? Shall we go ahead to the next one? Coming up on your screen. Ready? Okay. So what is this question saying? This question is saying the work done to move a unit pole, north pole, around a closed loop in a field is equal to the dash of the loop. Interesting question. What is it called as? Work done to move a unit pole. Let's see how many of you can answer this tricky question. Is equal to the dash through the loop is equal to the dash through the loop. Work done in moving unit north pole. Work done in moving a unit north pole once around a loop in a field is known as what? Think about it. So, my dear warriors, if you have a magnetic field line like this, remember magnetic field line is always going to be closed loop. Magnetic field lines are always going to be closed loop. So if you take a pole, if you take a polarity and you move it like this, and in that entire path, the total work done is W. That work done per unit pole, what is it called? It is called as the flux through the coil. It's called as a flux through that path, or that, you know, that loop and all that. Yes, it's a magnetic flux. No, it's not called current. It's not called current. It is called as the flux. Okay, cool. Yes, moving on. So remember this definition, that's all. It's also there in NCERT. Okay, so maybe some of you might be like, oh, I need to revise the chapter. Yes, definitely you will have to. The device used to detect the direction of the magnetic field. I want to know where the magnetic field is. What device do you use? Very simple. Everybody knows the answer. Everybody knows the answer. Come on. What is the device which is used to see where is the magnetic field? Come on, man. Everybody knows this. You might have seen this so many places. You might have used this also. I want to know. Yes, very good. Keep it up. Everybody started posting the answers. Compass. Magnetic compass. That magnetic needle, magnetic compass tells you where is north, where is east, where is west, where is south. Correct? Right? Very good. Rajavardhan, Krishna. So many of you. Anu. Awesome. Next one. The phenomena where an electric current is induced in a circuit because of a change in the magnetic field is called dash kind of induction. The phenomena, read it, where electric current is created inside a circuit because you are changing the magnetic field. So you have a circuit and you see current is created. You're like, oh, this is magic. No, it is not magic. That phenomena is called as what? Oh, come on. Second fill in the blank is already mentioned over here. The only word which can fit in is electromagnetic induction. Yes, not just magnetic, electromagnetic induction. The change in the magnetic field causes electricity. Magnetic field changing causes electricity. That's why electromagnetic. Why this word came induction? Induce means you are not touching it. Like, am I touching my hand on your head like this? Okay, come here, NEET students. Come, I'm going to bless you now. I'm going to touch your head right now like this. And now all my knowledge is getting transferred. That will be called conduction. I am talking to you wirelessly. You are sitting somewhere, I am sitting somewhere, that's all. So, that is induction. I'm inducing knowledge into you, right? And they say that whenever knowledge has to be induced, always you need to give that feedback to the teacher. In the sense, you need to be really humble. You need to, reciprocate. You need to support. You need to show that affection and that respect. And one way and the best way to do that is by offering Guru Dakshina. And the best Guru Dakshina that you can go on YouTube is by smashing that like button right now. So give that right now, or else that knowledge which had to be induced may not actually be induced. Remember that. Cool. Magnetic field exerts a force on a moving charge perpendicular to both velocity of the charge and what? And what? What is that next thing? What is that next thing? A magnetic field applies some force on a charge moving perpendicular to both the velocity and of the charge and the field. Yes, magnetic field. Remember this diagram. If you have a charge which is moving with some velocity, and then you also have magnetic field here, then if this is the angle between them, then you do V cross B, and you see that you will get the force. You will get the force. Force is Q V cross B. It's perpendicular to the field, perpendicular to the velocity. This is how the diagram looks like. So this is the diagram. If you remember it, you can easily answer this question. The direction of the force on a moving charge can be determined using dash rule. If you just paid attention to the previous question, this answer will be straightforward. You won't even spend 2-3 seconds on answering this. Come on, the direction of the force on a moving charge in a magnetic field can be determined using what, my dear students? You can use the cross product rule, or you can also use the Fleming's left hand rule. Yes, you can use the cross product rule, which is the right hand thumb rule, or the Fleming's left hand rule. So both filling the blanks can be correct. So depending on the options. So when I say the left hand rule, it is actually the Fleming's hand. It is not your hand, it is Fleming's left hand rule. But usually don't use Fleming's left hand rule. Don't use Fleming's right hand rule. Don't use left foot in your mouth rule. Okay, all these rules will be very confusing. So in Fleming's left hand rule, my thumb was this, pointed finger was this middle finger was this, what was this, sir? I got confused. Then students are doing this and this. Teacher sent that kid to the toilet only. Why? Because that kid was doing like this. So guys, don't do all these nonsensical things. Instead, just use your normal right hand thumb rule. Because the force is Q V cross B. You know how to do the cross product. Cross product everybody knows. So just use the cross product. Got it? Very nice. Moving on to the next one. The magnetic field produced by a solenoid can be increased by inserting a dash core inside it. Can be increased by inserting a dash core inside of it. What kind of core? Magnetic field can be increased. Come on, my dear students. If you want to increase the field, a material should be like, it is behaving like a permanent magnet. It loves a magnetic field. Who is that material? Is it diamagnetic? No. Para? No. Ferro? Yes. They behave like permanent magnets. So it must be a ferromagnetic core. Exactly. Next question. What does it say? The phenomenon of inducing voltage across a coil due to the change in the magnetic flux. Again, I think this is straightforward. I'm just going to skip it, but you should know it is mutual induction, electromagnetic mutual induction, same thing. All right. So you are inducing a voltage in a coil due to change in the other coil. So it's again electromagnetic induction, but it is mutual induction, right? In one coil, changes are happening, electricity is caused in the other coil. One thing changes, other thing gets affected. Like if Pandu gets hurt, Champa is getting affected by it. Pandu is hurt, Champa is getting affected by it. Like it happens with many, these couples these days. One couple is feeling sad, the other Champa is feeling also sad. So happens, right? So same thing, that is mutual. Okay. Device that stores energy in a magnetic field is known as, what is that device which stores energy in a magnetic field? What is it called as? Come on, my dear warriors. Magnetic field. I know a device which stores energy in electric field, that is called capacitor. Who is that other ter? Capacitor, resistor. Who is that other ter? Yes, sir, I remember. That ter is inductor. Very good. Not conductor. Inductor. Very good. Awesome. Thank you, Sensei, for all the love. Yes, and the support. Next one. The intensity of the Earth's magnetic field at a given location is measured in. You want to measure the strength, the intensity of the field at any place on the Earth. How do you measure it in? What is the answer? Listening to all of you in the chat box. Yes, it is in Gauss. Usually it is in Gauss. But yes, you can also measure it in Tesla. And we all know 1 Gauss is 10 to the power minus 4 Tesla, which I just gave it at the start of the session. Right? Very nice. Very nice. When you have a material that does not retain magnetic properties, when your external field is taken out, that kind of material is called as, it does not retain only. There are two kinds of materials. One is diamagnetic, okay, and the other one is paramagnetic. Both of them are non-magnetic materials. So it could be diamagnetic, paramagnetic, or in general they are said to be non-magnetic, but depends on what are there in the options. In the options, if it says diamagnetic, paramagnetic, ferromagnetic, and D option says both A and B, then you will mark option D, which says both diamagnetic as well as paramagnetic. Understood, guys? Clearo? Yes. Perfect, perfect, perfect. Moving on to the next one. The SI unit of the coefficient of self-induction. Coefficient of self-induction. What is the symbol? L. Self-induction. L. So what's the symbol? Come on, my dear students. Self-induction is measured in Henry. Hen laid eggs. Hen laid eggs. That's all. That's how you can remember it also. EMF is L di by dt. This is like your hen laid your eggs, right? Henry. Inductance, EMF. This is the formula of the EMF which is created inside a self-inductance. Very good. The opposition faced by an inductor to change the current, a change in current, is quantified by, quantify means you give it some value, you associate a number with it. What do you think it is? What do you think it is? When you have to face some opposition by an inductor, that property of an inductor, the name only came because of the property of inductance. Yes, that's the answer for it. A permanent magnet's magnetic properties are due to the alignment of dash domains. Something got to do with the domains. Guys, actually, this is very simple. The filling the blank should not have been this one. It should have been this one. So I think, there was a slight problem over here. But yeah, when you have a permanent magnet, the magnetic properties are because of magnetic domains. Yes, magnetic, ferromagnetic domains or magnetic domains. Exactly. So you will see that if you have a bar magnet, a big bar magnet, inside that bar magnet there are regions. There are regions over here, and in each region you call it as a domain. All the magnetic fields are aligned in a very peculiar direction. That is that section where all the magnetic fields are aligned in a peculiar way, that is called as magnetic domains. So that is what a ferromagnetic material is made of. When you take a charged particle, move parallel to the field, the magnetic force on it is, we just did the reverse of it. Come on. What is the answer to this? What is the answer for this? Very good. It is 0. QV cross B. QV cross B. Yes. So what happens is F is QV cross B. This cross will become sine 0, which is 0. So the force will also be 0. So the force will also be a big fat 0. The magnetic field lines outside a magnet move from dash pole to dash pole. Outside a magnet, move from which pole to which pole? Move from which pole to which pole? Think about it. Yes, they move from outside. Yes, north pole to south pole. I think we did something very similar to this from magnetic field lines outside. This was not supposed to be south pole to north pole. This was supposed to be north to south pole. Ignore it. I think, or else the word should have been inside over here. Okay, otherwise that answer is wrong. I'll get it changed. Okay, so technically the answer will be north pole to the south pole. Inside it goes from south to north, outside north to south, inside south to north. Okay, so I think the word should have been inside instead of outside. That's all. Okay, the dash effect is the deflection of a charged particle moving through a magnetic field. The dash effect. What is that effect called? What is that effect called? The effect which causes some deflection of a charge which is moving inside a magnetic field. That is exactly, very good. That word is the Lorentz force. The Lorentz force. Very good. Next one. The alignment of atomic magnetic moments in a material that results in magnetism is referred to as is referred to as, the alignment of atomic magnetic moments in a magnetic material is referred to as what, my dear students? Yes, magnetic ordering. Magnetic ordering. Okay, so the alignment of atomic magnetic moments in a material which causes that magnetic property is called magnetic ordering. The dash effect refers to the generation of an electric current by a moving conductor through a magnetic field. If you move a conductor through a magnetic field, something is produced. What is produced? EMF is produced. EMF is produced. So that EMF which is produced is because of which kind of effect? When you are moving a conductor through a field, you are changing the flux through the conductor, and as you change the flux, electricity is generated. Changing flux, creating electricity, that is none other than Faraday's law, Faraday's effect. Exactly. Okay. It is also referred to as motional EMF. Motional EMF, Faraday's effect, one and the same thing. Keep these things in mind. Moving on. Magnetic materials can be classified into diamagnetic, paramagnetic. Okay, this is very simple. You can easily spam it. I'll wait for your spam. I'll wait for your spam. Everybody can spam this. We have been doing this again and again and again. Again and again and again. So many times we have been doing this. Come on, come on, come on. Para, dia, ferro. Exactly. Ferromagnetic. Very good. Moving on. The magnetic force on a current carrying wire in a field is maximum when the angle between the wire and the field is. Angle between the wire and the field is how much? So that the force is maximum. Either the answer will be 0 or it will be 90 or it will be 45. Now which one will you choose? Will you choose 0? Will you choose 45 or will you choose 90? Think about it. The formula is ILB sine theta. So if you want the force to be maximum, sine theta should be maximum. And when is sine maximum? Sine 90 degrees is 1. That's the maximum value of sine. So the angle should be 90 degrees. Yes, very good. Raja, Made in India beats, Kirti Vasan, Malakorti, Sanvi, Rani, JK, Sunlight, Rachel, very good Krishna, very good Samira, very good, very good. The answer is correct. Next one. A loop of wire rotates in a magnetic field inducing alternating current due to the principle of, come on, come on, come on. So the complete magnetism we are doing today here. So make sure that you are watching this lecture as you are preparing for magnetic effects, currents, electromagnetic induction, all these concepts. Yes, the principle of electromagnetic induction. So when you rotate a loop, right, it produces electricity. This is the principle of AC generation. So you take a loop and you rotate it with some angular speed. And if you take the wires, there is an EMF generated which is given by BA omega n sine omega t. This is the formula. This is basically used for your generation of AC. Keep these things in mind. B is field, A is area, omega is angular speed, n is number of turns. That's all. The sign means it is increasing, decreasing, becoming positive, negative, up and down. Oscillations are happening. The measure of the magnetic field induced inside a substance relative to the external field is known as the measure of the field, okay, induced inside a substance relative to the external field. So there is some magnetic field which is induced inside, the magnetic field which is inside, and the magnetic field which is external. What is that ratio? What is that? You know, the measure of the magnetic field inside a substance relative to the external field. That is your relative magnetic permeability. How much is it permeating inside? Magnetic permeability relatively. Actually, relative word is missing over here, but it is relative magnetic permeability. Keep this in mind. Yes. A transformer operates on the principle of electromagnetic what? If you take a transformer, what is the principle in which it operates? Remember, there are primary windings, then there are secondary windings. You send electricity in the primary, then electricity is generated in the secondary. So from this coil to that coil, what is happening? Yes, electromagnetic induction, but it is mutual induction. This word should be mutual induction, not just induction. Mutual induction. Yes, mutual induction is the property. Exactly. Mutual induction. Right? So the correct word should be mutual induction. Next one coming up on your screen. The device which is used to measure the intensity of field, how strong the field is. There is a device for that. What is it called? You might be thinking, sir, will this kind of question come in NEET? Yes. Recently in JEE, they asked a question on spherometer. Spherometer is used for, just imagine, that kind of question came. So this question can definitely come. And then it will be clean bold question. Students will be like, oh my God, where was this in NCERT? I had never read it. But yeah, if you have attended my class, you would know that it is called as a Gauss meter. A Gauss meter is a device used to measure how strong a magnetic field is. How strong a magnetic field is. Okay, these kind of questions have come in JEE set by NTA, so highly probable it can also come in NEET exam. Now, materials with a negative magnetic susceptibility are also known as negative susceptibility. So the worst materials they are, negative means. So that is diamagnetic. Small positive is paramagnetic and largely positive are ferromagnetic. So negative susceptibility is a diamagnetic, small positive susceptibility is para, and the best with large positive susceptibilities are ferromagnetic. Okay, keep writing all these things down. It will be helpful for your NEET exam as well as boards. If you take a loop, magnetic moment is proportional to the current it carries, and it is magnetic moment is proportional to the current it carries. And one more thing, magnetic moment, what is it proportional to? Remember the formula, National Investigation Agency. Magnetic moment is the National Investigation Agency. So what do I mean by that? NIA, that is M. M is National Investigation Agency. So it is proportional to the current. It is also proportional to the area. It's also proportional to the number of turns. So that's the magnetic moment, NIA. Keep that in mind. The magnetic field inside a toroid is dash and is directed along the axis of the toroid. How many of you remember the formula of the toroid? And what is the nature of it? What is the nature? Toroid is like a solenoid, but which is in a circle. It's like a bent solenoid. It's like a tube, and you wrap a coil around it. That is a toroid. It is also going to go in circles. It is going to go in circles, and the formula is just like your solenoid only. So it looks something like this. This is your toroid. This is your toroid, and this is how your magnetic field lines go. This is how your magnetic field lines go. They are circular, and it is mu naught number of turns into current divided by 2 pi r, where r is this radius. R is this radius, complete radius, same formula, that's it. Moving on, Faraday's law of electromagnetic induction states that induced EMF is directly proportional to the rate of change of dash flux. Rate of change of which flux? Is it electric flux, gravitational flux, electromagnetic flux, magnetic flux? What is the answer? Yes, magnetic flux changing causes electricity. Changing magnetic flux causes electricity, so it is change of magnetic flux. Exactly. Moving on to the next one. Lenz's law. We are halfway through, guys. Keep it up, keep it moving. Do not lose that energy, do not lose that momentum, do not lose that josh. These few hours, the most important few hours of your NCERT preparation, which is useful for both NEET as well as boards. Make sure you don't miss these classes. Make sure you attempt all these questions thoroughly. We are revising NCERT. That's it. After this solving back exercise, everything will come. But at least be thorough through the NCERT lines. Lenz law gives the direction of the induced current and states that it will always oppose the change that what? Produced it. The change which was produced by it will always be opposed by Lenz's law. That's the meaning of Lenz. It's like, you say that I want to go and play outside. Then your parents are like, no, go sit and study. Then when you're sitting and study, what is this? You only sit and study, you don't go play outside. Always opposing. That is like Lenz. Understood? So always opposing the change produced by it. The device which is used to measure the direction and the strength of magnetic field is called as The device which is used to measure the direction and the strength of the magnetic field is called as the magnetometer, not as a Gauss meter. Remember that Gauss meter used to measure the strength. Magnetometer measures both the strength and the direction. So understand the difference. One word changes, your answer will change. Magnetometer tells you both the direction and how strong it is, but Gauss meter only tells you the how strong the magnetic field is. Completely different. Okay, moving on. Strength of a field produced at the center is given by mu naught I by 2r. Mu naught, I think we did this question, it just got repeated. Let's just move on. We have done that. The direction of the induced current in the conducting loop when the flux through the loop is decreasing is determined by dash law. Which law do you use to find in what direction is the magnetic what is the direction of the current inside the coil? Current is this way, that way. What is that law which you use? What is that principle which you use? What is that principle which you use? Exactly, that principle is none other than Lenz law. Remember, Lenz's law always tells you the direction. Yes. Oh, by the way, Lenz's law is based on which property? Lenz's law is based on which property? It is based on the property of energy conservation. Energy conservation. It always tells you what direction it should be, and it will ensure that energy is conserved, or else if it did not oppose, then magically new and new energy will come into space, right? That is not allowed. Okay. The magnetic field around a wire carrying electric current can be, I think this got repeated, I don't know why it's here again. Okay, moving on. When a current flows through a straight conductor, the magnetic, why is it getting repeated again? Something happened. Yeah, this one we can start off with. I think some questions just got repeated for some reason. I will be sharing the PDF with you. If there were some repeated questions, we'll ensure that those questions are replaced by some new questions later on. Okay, don't worry about it. All right. The interaction between a magnetic field and a coil of wire that produces a voltage is known as dash induction. When you see some interaction is there between a field and a coil of wire that produces that voltage, what kind of induction it is known as? Come on, my dear warriors. What kind of induction it is known as? Think about it. Yes, the interaction between a field and a coil of wire that produces voltage is known as electromagnetic induction again. Yes, perfect. Okay. So the angle of dash is the angle between Earth's field of direction and the horizontal place. If you are at any point on the Earth, the direction of the magnetic field and the horizontal direction. Earth's magnetic field will be in some direction. The actual horizontal will be in some direction. The angle between the horizontal and the Earth's field, the angle between them is called how much is it dipping by? How much is the dip? The dip angle. Yes, the dip of the angle. Yes, correct. The dip. Transformer's efficiency is affected by its core material, which is usually made of dash to minimize energy loss. This question has been repeated in NEET in the previous years also. You would have seen this. What do you think is the correct answer for this? This is very, very important. Filling the blank. Very, very important NCERT line. This has been repeated a couple of times in different exams. So as to improve the efficiency, what you do is you want to minimize the hysteresis losses and all of that energy losses. So what you do is that you laminate the core. You laminate the core. Yes, you laminate the core to minimize those losses. Yep, not ferro. It is made of laminated core. Yes, iron is there. Why is iron used? See, understand, why is it made of iron? It's to remove flux loss, not energy loss. Read the words carefully. If the word is flux loss, to minimize flux loss, then the answer will be iron. But that iron has a coating, lamination. Like your Aadhaar card has a lamination. Same way, the iron core also has a lamination. Why is that lamination? For reducing those energy loss. Understood? Iron is for flux loss, lamination is for energy loss. Two different things, two different answers, and you might make a mistake. You might get a negative mark. So that's why these things are very important. Okay, moving on to the next one. The phenomena, I think, why is this question getting repeated again and again? Something went wrong. I'll get these questions removed, okay? Materials with magnetic permeability much more than 1 are known as magnetic permeability. They are permeable. They are having very large values. What are they called as? Yes, they are called as ferromagnetic material. Exactly, my dear students, they are called as ferromagnetic material. Yes. So para is slightly permeable, less permeable. Worst is dia, negative susceptibility. Dia, it go diamond, like that it is, negative. Para is slightly positive, slightly, P positive, slightly, susceptibility is positive, slightly more permeable. Ferro, the name only has so much of weight in it, like which is used for making permanent magnets or horseshoe magnets, that is most permeable and has most susceptibility. Okay, what is this? Is proportional to mu naught Ni. The magnetic field inside a solenoid is mu naught Ni. The formula indicates the field strength is directly proportional to both the number of turns per unit length and the current and the permeability. Number of turns per unit length and the current. Yes, both of them. The dash effect occurs when a conductor. Why has the questions got repeated? Faraday's effect, we just did the question. Okay, next rule, let's see. 67th question. The dash rule can be used to find the direction of the magnetic field around the current carrying conductor. What do you think it is? What do you think it is? Come on, my dear warriors. Yep. Which rule will you use to find a direction? You take the right hand rule, right hand thumb rule. Yes. You hold the conductor such that the thumb points in the direction of the current. Current is going up. Okay. The fingers tell you how the field lines are moving. The fingers tell you how the field lines are moving. The dash hand rule is used to find the direction of the EMF or the current as a result of changing field. Now, what is the answer for this? Slightly different question from before. This was the answer for the previous one. What about this one? The which hand rule is used to find where is the EMF or the current when you have changing field? Which hand rule is that? Which hand rule is that? That is the Fleming's right hand rule. That is the Fleming's right hand rule. Yes, you use the right hand rule for determining the EMF. That's why I tell, don't remember that Fleming. Although from board's point of view, it might be important, or maybe theoretically it might be important, but practically never use Fleming's left hand rule, right hand rule. Left hand rule is for force, right hand rule is for EMF. So difficult to remember all these things. Better to always use cross product. Cross product. Okay, keep this in mind. Moving on. Repulsive or attractive forces between two poles varies inversely with the square of the distance between them, similar to the dash law of electrostatics. Is this law very similar to some electrostatics law? Is it very similar to some electrostatics law? Yes, it is. It is similar to which law? It is similar to which law, my dear warriors? It's similar to Coulomb's law of electrostatics. I think this question only changed, but yeah, it should be Coulomb's law of electrostatics. Is that cool? Coulomb's law, Q1 Q2 by R square into K. Here it is some constant which is mu naught by 4 by M1 M2 by R square. Magnetic pole 1, magnetic pole 2 by R square into that constant is mu naught by 4 pi. Keep this in mind. I think the slides got slightly misarranged for some reason. Not sure why, because of some reason I'm not sure. I'll get it corrected when you get the PDF. Okay. Anyways, dash is a loop or a coil of a wire that can carry an electric current and produce a magnetic field. A dash is a loop or a coil which can carry some current and produce magnetic field. Who is that? What is that device called? Everybody knows this. It's an electromagnet. How does an electromagnet look? You take a core, you have some windings, that windings carry current and they produce magnetic field. So that electromagnet looks like a long pipe, is nothing but a solenoid. Solenoid. Very good, very good, very good, Rani. Excelente, excelente. Now, when you have some electric current which is inside a conductor which is moving in a magnetic field, when you take a conductor and you move it inside a magnetic field, that is motional EMF, and that is because of which effect? That is because of the which effect, my dear warriors? Faraday. Yes, Faraday laws of changing flux creating electricity. Dash material, yes, a dash material does not retain magnetic property when you remove field and has relative permeability less than 1. I just was mentioning about 3 materials, dia, para, ferro, and I described the general characteristics, so that might help if you remember it. If you take a material, it is not able to retain any magnetic field or property. 100% it is not ferro, so either it is dia or para. Now the next piece of information says permeability is less than 1. Permeability is less than 1 means simple. It is a diamagnetic material, right? Isn't it? Exactly. Para will be slightly more than 1. Para will be more than 1. Great. Moving on to the next one coming up on your screen. I'm not sure why the questions are getting repeated. North Pole to South Pole. We had just done this. I'm skipping this. Okay, again. All right. Okay, the direction of the field produced by a current carrying loop at any point on the axis of the loop is determined by which hand rule? Okay, this is a new one. Let's see how to solve this. Come on, my dear students. If you take a coil, and it has some current carrying wire, okay, then the direction of the magnetic field, how do you determine it? Simple. You take your right hand fingers, curl it in the direction of the current. Automatically your thumb will point in the direction of the magnetic field. So it is your right hand thumb rule. Right hand thumb rule, right? So what is it? Right hand thumb rule. Exactly. Right hand thumb rule. Very good. The magnetic field inside a current carrying straight conductor is dash around the axis of the conductor. What is the correct statement or word which will fit in over here? If you take a straight wire and you see the dash around the conductor, the magnetic field line is, how is it arranged? You will see concentric circles. Yes, if you have a wire like this, the magnetic field lines will be like this, like this, like this. This is how the magnetic field lines will be, isn't it? Yes, that is the correct answer, my dear warriors. If you take a transformer, the ratio of the turns in the primary to the number of turns in the secondary determines the turns in the primary to the secondary. What does it determine? It is determining the something called as N1, N2. Divide it. What do you get? N1 by N2. This is called as the turns ratio, which is also the voltage ratio. V1 by V2 is N1 by N2, which is also the turns ratio. Exactly. That is the formula. Voltage ratio, turns ratio, one and the same thing. Voltage and turns are directly proportional to each other. Moving on. The phenomena where electric current is generated by varying magnetic field. We have done this before. I will make sure that the questions don't get repeated next time. But yeah, it's the electromagnetic induction. Moving on. Material that can show some attraction to field and permeability is slightly more than 1. When the permeability is slightly better, then it is neither dia, it is neither ferro, it is in between, it is para. and it shows small amount of attraction. Yes, it is paramagnetic paramagnetic material. Okay. The unit of magnetic moment is dash meter squared per ampere. This is going to be an interesting one. Let's see how many of you are going to tell me the correct answer. The unit of magnetic moment. Magnetic moment. Remember the formula? National Investigation Agency, NIA. From that you can easily get it. Easily get it. Yes, ampere squared meter square. Wait, let's see if there is some mistake over here. Magnetic moment is NIA. So what is I? I is nothing but current, so it is measured in ampere. What is A? It is nothing but area, so ampere meter squared. So is ampere meter square, and I think this has been chumma. Yeah, chumma was there over as a misprint. This should not have been there. Ampere square meter, ampere meter square, or you can just probably remove this and you can just keep it like this. This is a better way of writing it. Ampere meter squared. This should be the correct answer. Okay. So I'm just correcting it over here just in case. In the PDF everything will be corrected, don't worry. Magnetic field exerts a force on a moving charge that is perpendicular to the direction of both the charge's velocity and, yes, V cross B, QV cross B is the force. So force is perpendicular to velocity as well as the field. As well as the field. F is Q, V cross B. Velocity and field, both of them, the magnetic field is going to be, magnetic force is going to be perpendicular to. The dash effect describes how a current carrying conductor experiences a force. Why are the questions getting repeated? Yeah, it was not supposed to happen, guys. Okay, next question we'll go to. Okay, residual magnetism left in ferromagnetic material after an external field is removed. If you remove the external field, even then some magnetic properties are remaining. Remaining. What is the word similar to remaining? Think remaining, remnants. That property of whatever is remaining, even if when you remove the external field, whatever is remaining, remnants, yes, that is the correct answer. That is remnants. Correct, correct, correct. Very good. Excellent. Moving on. Dash materials are those in which the magnetic field lines are the most closely packed inside the material. What are those materials where it is very closely packed? Where it is very closely packed. What do you think are those materials called as? Yes. What are they called? Ferromagnetic? Very good. Very good. Very good. Ferromagnetic materials is the correct answer. Yep. Yep. Moving on. 100 questions, Rachel. 100 questions. The process of generating a steady magnetic field with the help of current is called as dash magnetization. What is this called? What kind of magnetization is this called? If you are generating a steady field with the help of current, you are creating magnetic field. You are creating magnetic field that is called as electromagnetic magnetization. It's basically your Biot-Savart's law at the end of the day. Biot-Savart's law at the end of the day. When you have a current carrying wire, it produces magnetic field around it. It's an electromagnetic magnetization. That's all. Okay. A device that measures small voltages by converting them proportional to the displacement using electromagnetic effects is known as a device which measures some voltages by using some mechanical properties, mechanical displacements using electromagnetic effects, meaning there is a magnet inside, there is a coil inside, you pass some current, the coil gets deflected, and based on the deflection you are able to measure how much voltage is there. What is that device called? Yes, it's a galvanometer which has been converted into a voltmeter. A galvanometer which is converted into a voltmeter. Yes, perfect. So that measures voltages, it measures small voltages, remember that. So when you want to increase the range, that's when you connect a resistor in series or in parallel, depending on whether you want to make use of it as an ammeter or voltmeter. Yes, correcto, correcto. Moving on to the next one. Dash rule is used to measure the direction of the force on a current carrying wire. Whenever force is measured on a wire carrying current and it says which rule, well, you can use cross product, but Fleming wise, it is Fleming's left hand rule. Remember, Fleming left hand rule is for current, force and your magnetic field. Fleming's right hand rule is for EMF, velocity, motional EMF. So those are two different things, left hand rule and right hand rule. Don't remember what those rules are, completely useless for our NEET perspective, but for board perspective, yes, it can be asked. Dash currents are induced in currents in bulk pieces of the metal moving through a magnetic field which causes energy dissipation as heat. What is this? What is this, guys? Some kind of currents are created in some bulk pieces, meaning some chunks of those metal pieces. When some energy losses are being created, it's lost as heat. What is that kind of current called as? A very famous current useful for braking in high-speed trains, that is called as eddy currents. Yes, eddy currents is the answer. So they are random current loops and they are formed in small places everywhere in that conductor, and that causes I squared R or heat losses. That's it. The energy is lost completely. That is your eddy current loss. Very good. A loop of coil of wire that rotates in a field produced to produce AC electricity, basically generator. You have a coil, you have a loop, it rotates so that electricity is created. Remember, I just gave you the formula, Born sine omega t, BA omega n sine omega t is the EMF. So that loop which rotates in the magnetic field, what is it called? It's called armature. Yes, armature. If you remember the AC generator diagram, labeling should be remembered. Then you will remember it is called as the armature. There are slip rings. All those things are very important. It can come in your boards if you are a 12th standard student. Sometimes maybe asked in a different way in the NEET exam, like match the following or just filling the blank with options. Ability of a coil to store energy in the form of magnetic field is quantified, is given in value. Ability of a coil to store energy in a magnetic field is called as, come on, what is it called as? There is a capacitor stores energy in electric field. Resistor causes losses. Inductor is the one which stores energy in the magnetic form. So it is inductance. Inductance stores the energy in the magnetic field. Very good. The alignment of magnetic moments in ferromagnetic materials below certain temperature results in, that temperature is a critical temperature, Curie temperature. Below that Curie temperature something happens, and what is that? You will see that below that material is a ferromagnetic material. Above the Curie temperature it is para. Para is temporary, ferro is permanent. So when you heat something, that ferro becomes para. When you cool something, that para becomes ferro. So as you are cooling below that certain temperature, the para converts into ferro. It is getting magnetized and it is going to get spontaneously, immediately below that temperature, it becomes spontaneously magnetized immediately. Now below the temperature it is ferromagnetic, above the temperature it is para. Keep these things in mind. Lower temperatures it is permanent. If you heat a magnet, it becomes temporary magnet, means para. So when you cool a hot magnet, it becomes permanently magnetized. Below the temperature, immediately it gets magnetized. The dash effect is the phenomena. We have done this again. Faraday's effect. Why is it come again? Need to get these slides corrected, my dear students. So sorry for this. The opposition of the flow of the AC current in the circuit due to capacitance or inductance is called as, the opposition to the flow of AC current is called as what, my dear warriors? When you pass some AC, not DC current, and that opposition which is created, what is it called? See, if the word was DC, the opposition to the flow of DC is called as resistance. But the opposition to the flow of AC, that is not called resistance, that is called as reactance. Inductive reactance, capacitive reactance. So reactance is the word. Reactance is the word. Okay, moving on. A material with permeability less than vacuum. Is it possible? Answer is yes. Who is that? Such a loser kind of material, such a waste, go die. Diamagnetic. Go waste fellow, die. So diamagnetic material which has permeability less than that of vacuum is diamagnetic. Yes, awesome, awesome. Okay, okay, okay. Bohem, definitely, I heard you. What if I tell you, I will give you all the NCERT question solutions very soon. Do you want me to give it to you as a gift? All the NCERT solutions. All the NCERT solutions. Do you want me to give it to you? Yeah. Right. Chalo. So that is a next surprise. So it will be a surprise for all the students who are not a part of this video. But if you are a part of this video, then you will be desperately waiting for that particular announcement, which I'll be making very soon. Right? Cool. Awesome. So magnetic field strength at a point away from a long wire, current carrying wire, varies inversely with the dash from the wire. What does it vary with inversely? Inversely with the distance. The distance from the wire. 1 by r it is proportional to, not 1 by r square. A lot of people think 1 by r square. No. Mu naught I by 2 pi r. Mu naught I by 2 pi r, not r square. So inversely proportional to the r value, which is distance. What is the process by which a magnetic material becomes magnetized in the direction of the applied field known as? If you apply some, process and by which the material becomes magnetized in the same direction of the field, what is it called as? What is it called as? What is that property? It has got magnetized. So that property is magnetization. Yes, it is called magnetization. It has got magnetization. Okay, right. The symbol for that is I. The symbol for that is I. Magnetizing field is H. Magnetization is I. Magnetizing field is H. Two different things. The dash is a theoretical concept used to represent the strength and the direction of the magnetic field. The dash is a theoretical concept to represent the strength and the direction of the magnetic field. What is that theoretical concept? It's not there in reality, but in theory, in visualization. What do you visualize? To see how strong the field is. Where is the field going? Yes, you draw the field lines, magnetic field lines and everything, and that is given by the magnetic, of strength and direction of a magnetic field. It could be also, not sure why this has come. A magnetic dipole moment is a theoretical concept to represent the strength and the direction of a magnetic field. Well, you can say that as well, but you can say magnetic field lines is a better way. Although magnetic dipole moment shows you what direction a bar magnet's magnetic properties are aligned in. A magnetic moment represents what direction a bar magnet's magnetic fields are aligned in. So it is a debatable thing whether we should put this. It depends on the options, but technically it should be, magnetic field. All right. In the context of magnetism, the term saturation refers to the maximum extent to which a magnetic material can be. The context of magnetism, the term saturation refers to the maximum extent till which a magnetic material can be what? What is the maximum value till which you can, what do you do it? You are magnetizing it. After a point, it can't be magnetized further. It is saturated. So that limit till which it can be saturated refers to the maximum extent by which the magnetic material can be magnetized, I believe. Yes, magnetized. Correct. Very good. Moving on to the next one on your screen. Induced voltage in a coil changes when the dash flux through the coil dash. To filling the blanks. What should be the answer? induced voltage in a coil changes when which flux? Magnetic flux through the coil changes. Exactly. Magnetic flux inside the coil should change. Then you will see electricity is being created. That is your Faraday's law. Next question. The Fleming's dash rule is used to find the direction of the dash in a generator. What does a generator do? Creates voltage. So for voltage, which Fleming's rule will you use? Remember, left or right? Will you use left or right, my dear warriors? Yes, you will use left for force, right for voltage. Left for force, right for voltage. So voltage is being created in a generator. So you will use Fleming's right hand rule for the voltage or that current which has been created. Correct. Not the left hand rule. You can get confused at times over there. All right. In a magnetic field, the path taken by charged particle is often spiral. So it is spiral in nature because the force on it, which is dash to both the velocity and the particle and the direction of the dash. This is Lorentz force. Force is QV cross B, if you remember the formula. So from that you can understand force is always perpendicular, because of which the particle's path is always curved. It is spiral in nature. So the force on it, which is perpendicular to both the velocity and the field. Force is Q, V cross B. V cross B, it is perpendicular. Cross product means perpendicular, right? So that's why that should be the answer. Okay, so these were the questions of physics. Now it's time for biology. Whatever questions were repeated, I'll make sure that in the PDF when you get it, they are corrected and you will get those new questions. Okay, so stay tuned on the channel. You will be definitely getting the PDFs in the days to come. But now it's time for biology. Make sure you are subscribed to the channel and you're smashing that like button. Show that love, show that energy, show that support, guys. Okay, for your Gopika ma'am and your Baswa sir. All right, coming up on the screen. I hope they are in the... Yes, I can see them in the chats. I am stopping the session, ma'am.
Students, are we live? 1 second, let me check. Yes, we are live. Students, today I'm doing it alone, okay? We do not have Baswa sir. Right? Yes, ready? Come on, let me know in the chat box. All of you disappeared.
Can I enter?
No, you
the
can't.
class?
No, you're late. No, you're late.
Can I enter the class, ma'am? Give me the permission. Ma'am, can I get into the class?
You're late. Wait. Where are all the students? Okay, let's see. I think all of them ran
Hey,
away.
students,
Yeah?
I hope everyone is safe and sound and doing extremely well. This is Baswaraj.
This is Gopika. Welcome to
Vedantu
Vedantu NEET English. We are your
biology master teacher.
teachers.
Oof,
Yes.
So much in sync, no?
But then students, where are them? They all ran away, yaar.
Ran away, huh?
Yeah, they went off for break. Come on, let's
Ayyo.
call them.
Students, go and call everyone fast. As soon as possible, call everyone because we'll be doing not one. In fact, we'll be doing 2 chapters. Yes, we'll be doing human reproduction. Along with human reproduction, we'll also be doing the reproductive health.
Yes.
Can we start?
Let's see,
Yes,
let's see.
I am late. Yes.
I don't, students, I'm very strict, no? When it comes to late and not liking the session, bunking class.
But they're already answering the question, ma'am.
We are not taking this. We actually displayed last time, remember?
Huh.
Yes.
I
now
think the
we are-
question was there last time, so the same question has been taken.
This was trial round.
Yes.
Ready?
Hello,
Yes.
hello, Crazy. Hello, Shubhashini was there who spoke to us.
Yes.
So
Subhashi.
students, we'll be going live also on the Telegram, right? In Telegram, you can actually talk to us. It is not just we talking to you. On Telegram, if you come live with us, you can also talk to all of us and, generally have a discussion,
Exactly.
right?
Okay. Yes, thank
Can
you,
we start?
Siri. Yes, hi, Malar. Malar is telling only hello, sir. Not telling hi to me.
Nice. I like him. I like him. So students, let's start. And one more thing. This is going to be a rapid fire. I want none of you should have your NCERT open or any book. Don't write even a single word. Do not write a single word anywhere because the entire PDF will be given to you on the Telegram channel.
Yes.
So all you need to do is take your phone, start typing fast. Let's see who's
Yes, and students, there's also a thing that we finished this chapter, so it is a revision for you. So do not keep your NCERT open. Just keep your mind open. Just keep all your brain cells active, because we are going to do that, because these chapters are done. Okay, ready?
Can we start?
Yes. They're not telling hi to me, so I'm not going to tell hi to them.
Okay, students, everyone, some red hearts in the chat for Gopika ma'am. All of you.
Okay, let's start.
Start.
Okay, first question. Sir, please continue reading.
The humans are sexually reproducing and dash organisms.
I think
Yes.
answers are already on the
That is
chat.
viviparous. So students, we know humans are sexually reproducing because we know in the case of humans there is fusion of gametes. Yes, there is fusion of gametes. That's why sexual reproduction.
Yes.
Clear. Next question.
Okay, next question.
Next question.
Can we have the
Ma'am.
light changer? Okay. The reproductive events in humans include formation of gametes, that is sperms in males and dash in females.
Very
Come
easy
on.
question. Ma'am, class 8th level question. No.
Yeah, totally.
Class 8th level question.
Let's
That is
see.
reproductive events
We
in
have to
humans.
wait for them, or else,
Okay.
you know, they'll
We'll wait
be
for
like, oh no, ma'am didn't wait for us.
Still first. Answer. What is the answer?
I think that,
chat is lagging there.
No. Here.
Ovum.
Yes, crazy dude.
Yes. Ova or ovum?
Yes.
Ova or
Ovum.
ovum?
Even they can write egg also. I don't think it is wrong. Because
Yeah.
from 8th standard you study egg and sperm, right?
Yes. Students, but do you also study another word in this chapter? We also study something called as secondary oocyte also. That also you can write here.
Yes.
Next question, ma'am. Can I
Right.
read? The fusion of male and female gametes lead to the formation of...
Gosh, come on. Baby question.
All these are baby questions.
Starting introduction to all the chapters
Yes.
will have very simple
Good
questions. Later on we build up, no? That's how.
True.
Yes, come on, share the link with all your friends, yaar.
I think
What
so
is this?
less people here. Where is everyone?
Where's the regular students?
We don't want to do like NCERT line by line revision with us, because this is going to be the fun session. Because this is where you just open your mind, as ma'am said, and then sit with us and type the answers.
You're following my opening the mind statement. No?
Yes, I'm copying it.
Thanks.
Yes. It's the
Zygote. They have
Yes.
full answer.
formation of zygote. Now, quickly tell me in the chat, is the zygote haploid or diploid?
Yes.
Simple question. Now, little bit extra we are adding. Tell me in the chat if the zygote is haploid or diploid in nature. Cool.
Come on.
Next
Yes.
question, ma'am.
Ooh.
Okay.
Alright. Sperm formation in males continues even in the old age, but the formation of ovum ceases in women around the age of dash years. I don't know this why for males it's not it's continuing, and for
Ma'am, the thing is, even though the males are able to produce even after years, the sperm is not
not
viable. Then they become oligospermic in nature.
wow, diploid, very good.
Amazing. Everyone knows.
Yeah.
So this NCERT, according to NCERT, it is 50 years, but now according to the recent studies,
40 to 50.
50 to 50, it's decreasing on, right?
Because of the hormonal changes, lifestyle and all. No,
Everything.
even for some people at 45 menopause is happening.
Because even the menarche is starting very soon.
Yeah,
So
yeah.
initially, before back in the days, it used to be around, the female child reaching class 8th, class 9th, class 10th. Now even class...
Oh, there was a woman called Safina or Safia something. She gave birth to a child when she was, I think she was 90, 80
80
something.
years old.
Yeah, that is one of the records actually. If you
Is
search,
it
no? Yeah.
normal delivery, cesarean? Any idea?
No, that much I didn't read. I was shocked with.
You were like, can't comprehend so much. Okay, next question, ma'am. The male reproductive system is located in the dash region and includes testes and axillary ducts.
Come on. Yes,
Quickly.
45. Some have told 50 years. Yes, students, correct.
Yes.
If you search now, you might see 45 to 50, but actually according to NCERT, it is 50.
Quickly tell me in the chat.
Hi, Vignesh.
Hello, Vignesh. Sanvi is here. I say Sanvi's name all the time.
She's my regular student.
She is my student also now.
I don't know.
Okay.
Vara Lakshmi. She's also. I can never pronounce her name, but still she.
Varalakshmi.
Yeah, she still attends all the class.
Beautiful name.
Yeah,
Varalakshmi.
I keep telling Vara Mahalakshmi. I don't know. It comes naturally, no? Vara Mahalakshmi.
Mahalakshmi.
This is a very
Beautiful
South
name.
Indian thing.
Yeah.
Okay, students. Pelvic region.
Now, students, it is when we understand the pelvic region, it is actually between the two coxal bones. You will be studying in locomotion chapter next.
We have to break bones.
In locomotion chapter, you will be studying about it.
Yes. Abdominal or pelvic region. Thank
yes.
you. Yes, Pranav. Correct.
Now, ma'am.
The testes are situated outside the abdominal cavity within a pouch which actually regulates the temperature for
Ma'am,
the...
you explain them, I'll write them.
Yeah, okay, sure. But wait, let's see the answers also.
Yes.
Yes, So students, testis is located in a pouch, and that pouch provides 2 to 3 degree less,
Temperature.
regulate the temperature from the body temperature. So it allows the sperm formation, right? So that is why. Yes,
Exactly,
very good.
crazy. Scrotum.
Remember we had last class a bantan who was very fast.
She.
She it was. Yeah. She.
She.
Oh, now the chats are
Everyone,
moving.
yeah.
Very good. Okay, next
Come
question.
on, we need more energy in the chat. Why is everybody so slow? Come on.
Yes. Yes, very good evening.
Good evening. Next question, ma'am.
Each testis has about dash testicular lobules. Come on, the number.
Number is important here.
I expected this much number today in live watching, yeah. The students didn't share with friends,
What is happening here? Okay, sorry. Everything went blank.
Yeah, I think it's just some glitch.
Come on, answer. There's the number.
Yes, very good.
We got the answer here, huh? Yes.
Yes, Sanvi has written first.
Yes, Sanvi.
Very good.
250 testicular lobules.
Come on, students, share it with your friends and let's make 250 live watching. Come on.
Yes, that's the aim. First, everyone should like the video because we just see 200 likes, that's all.
Yeah. Students, like the video.
Let's make it 300 before we give us a target, ma'am.
Yeah. Last time we put, okay, let's put 715.
715. Okay, before 715, we need to make it 300 likes. Let's see if we can make it or not.
It's a challenge to you people. Okay, you can share it with your friends. You can post it on WhatsApp. You can post it on your Telegrams. Do anything, but we will try to see if you can make 300 likes. Come on, that
Next
much you
question.
can do, students. That much you can.
Next question, ma'am. The seminiferous tubule in the testes are lined on its inside by two types of cells. One is dash, other one is called as Sertoli cells.
Come on, let's see the answer.
Now, students, here one line is missing, ma'am. That is each testicular lobule will have 1 to 3 seminiferous tubule. That is also very important. Okay.
Yes, waiting for the answers. Come on.
Yes, waiting for the answers. Everyone, come on.
You people told, thank you. Okay, yes,
Exactly.
very
Male
good.
germ cell.
Who told first? Janvi.
Sanvi.
Janvi. No, Janani. Is it going blank?
Yeah, I don't know why.
Okay.
So, students, quickly tell me in the chat, the male germ cell is also called as, what is the other name of male germ cell? Quickly, let's see who is the first person to say the answer to this question. The male male germ cell is also called as
Sperm gel.
No. Someone is saying Leydig cell. Students, Leydig cell is not present.
It's actually a confusion.
Uh-huh.
It's easy. Why you done? Two types of cells. Sertoli cells, Leydig
Leydig
cells.
cell.
It's easy to tell also.
So, students, remember Leydig cell is present in the interstitial space outside the seminiferous tubule. Clear?
You'll get questions on that. Do not worry. Do not worry. Very good. Spermatogonia. Very
Clear.
good. Okay.
Ah.
Okay. Next question.
Next question,
Finish
ma'am.
right, please.
Finish writing, ma'am, first. Then we'll go to the next question.
Yeah. Okay. Leydig cells are located in the dark spaces between the seminiferous tubules. I think
We got the answer already.
I didn't say. Yes, Pranav. Give us time to write, Pranav. Very good. Tabsif bin. Okay, interstitial cells.
Yes, it's all interstitial space, and Leydig cells are also called as interstitial cells.
Yes.
Called, ma'am.
Yes, next question. Come on.
The
Okay.
male
Okay, no, read it.
The male axillary glands includes seminal vesicle, dash, a paired bulbourethral glands.
Yes, come on. Interstitial spaces. Very good. Students, give us little time. We need to write. Okay, that's the only delay. Otherwise, we are looking at your answers. So we want you to answer. Otherwise, later you complain,
Now
Mom, you didn't give time to answer.
Ma'am, here one question usually asked here is, see, seminal vesicle is paired. Bulbourethral is also paired.
Then who is that single
person? Who is that one person who's always single, sitting in a corner?
Like
exactly.
them, like our students.
Like a student. A single person here is the prostate. Exactly. The single person is prostate. Now here, bulbourethral gland is also called as Cowper gland.
Yeah.
That is not in NCERT, but you should know that.
But yeah, I think later on in your BSc, MSc, even in MBBS, it will be used very commonly.
Cowper gland.
Yeah, because I don't know, we never used to know bulbourethral.
We used to Cowper gland only, we used to know.
Yes, next
Next question.
I'll read it. The female reproductive system consists of a pair of dash along with a pair of oviducts, uterus, cervix, vagina, and the external genitalia. Come on.
Easy question, ma'am, again.
Thank you, Vijayan. Thank you, Vijayan.
Jen Sawyer. Ma'am read it actually.
I saw Vijayan. See, I read it. I can find you when you're writing a comment.
Yeah.
Okay, come on. Next question. Easy question. Go for it.
Ma'am, easy question. Ovaries this is the easy question.
Yes.
Clear? Next question, ma'am.
Yes, ovaries. Very good. Okay. The dash are the primary female sex organ that produces the female gamete. I don't think we need to even wait for the answer.
Right also, ma'am. This ovaries.
Ovaries.
Not right also this one, ma'am. Ovaries is the primary female sex organ because it is able to produce the gametes and also the hormone. Yes.
Good job. Okay, next question.
Ma'am, here when I was teaching chapter, I told about your class also. I told them that the hormones is a steroidal hormone, is it lipid soluble, water soluble, all that.
Okay.
I was watching a session then.
I think you also spoke about diapedesis.
Diabetes. Oh, you watched, huh?
Yeah.
Diabetes.
The white cells squeezing out.
Exactly. The amoeboid movement.
Yeah. Okay, go for it.
The oviducts are also known as dash extend from the periphery of each ovary to the uterus.
From ovary
to the uterus.
What is the
other name of oviduct?
Come
Very
on.
easy question. So students, I'll tell you one thing here. Questions like this will not come in your NEET examination. The question answer might be the same, but the question framing will be different. It will be difficult.
So in that we cannot do anything because we are not English teachers. We cannot paraphrase it and give it.
Yeah.
But the thing is, understand the answers will be the same. Concept will be the same. Wordings also. See, ovary and uterus, they cannot change it. Right? And the name, other name for oviduct also. Then, but the way of framing it.
Exactly.
That
the way
will
that
be
you change.
different. Okay? Fallopian
Tube. Cool. Now, students, you can see that what you learn from this our entire session is they usually ask you statement-based question from this chapter. So all the statements, each individual statement can be asked as a
full gibberish.
I don't know why. Picking up the Gopika ma'am.
The part of the ovary that is funnel shape, that has a funnel shape end is called as. Come on, tell me the answer. Okay. Students, we are training you in a way that you know the NCERT line by line. Sometimes when you read NCERT, it's not easy to remember everything. Even when we teach also, it's not easy to remember the NCERT concepts we know, but then lines is difficult. So this will actually help you understand what kind of question is coming, how much can they twist. They cannot twist it to so high level also that you cannot even think of the answer. Yeah. Correct? Yes, very good. Infundibulum. Okay, next question. Finger-like projections on the edge of the infundibulum is known as like this, like this.
Which will help in like this. Which will help in picking up the egg.
Yeah. I don't know. I keep saying over.
It's same anyway.
Come on. Tell me the answer. Yes. Students, 300 likes before 7:15. Can we do that? I think we can. Yes, very good. Fimbriae.
I wrote already. I wrote already. Next question.
Yes, next question.
The female reproductive system includes the uterus, which is referred to as dash.
Easy. No problem, Vijay. Thank you so much.
much.
We see all your comments, students. We like all your comments. We might not reply every time because we'll have to reply for every comments. We feel like,
true.
That's why we always like your comment. If you are getting one like immediately, that is our like.
Sunvi. Exactly.
Yes, very good.
Boom. So what we do is we usually write, we always see your comments all the time. Every single comment we'll see. We just like the comment and then...
we don't reply, that's all. Okay, yes. The dash is the narrow region of the uterus that opens into the vagina. I happen to tell this in reproductive health also.
Okay.
Because you remember, if you have watched Friends, Rachel's, they keep measuring cervix. Yeah.
Exactly.
The nurse comes in and they'll be like, no, it's not expanded. 3 meters, 4 meters. So, yes.
Then the Ross comes in and tells Briggs Ashton some contraction something, right?
Yes. Rachel, oh my god, there's the Rachel in our class when I just spoke about Rachel. And she's asking, ma'am, where can I get student weekly mock test link is in the description.
Also,
if it's not there in this description, go to any of our class description and check, it will be there. Okay, yes, very good. Cervix or cervical canal. Spelling correct? Okay. Next question. Very good. Something is happening, no? I think it's the... Okay. The external genitalia... I don't know why genitalia is coming out.
External genitalia and female...
Females include the dash, which is a cushion of fatty tissue covered by the skin and the pubic hair. Okay, what is that area called as? Come on. Which has the fatty tissues and covered by skin and pubic hair.
No.
No, not
No,
vulva.
not vulva. Vulva is actually not given in the NCERT also.
Yeah, vulva is not mentioned.
Not mentioned anywhere. Yes, Mons pubis. Someone wrote. Sridhar.
Srinidhi.
Srinidhi.
Very
Srinidhi.
good, very good. Mons pubis. It's also called as Mons Venus, Venus, however you want to pronounce it. Venus. And it's also called as a pubic mont.
Pubic mont. Yeah.
Yes, very good, very good. Okay, next question. The dash are the paired folds of tissue under
The
labia majora. We have so many pronunciation here. Majora. Come on, next answer.
Mons pubis, yes.
No, they're in the
in the previous one.
Let's see here if they have come.
No, that's very slow now.
Students, did you share the link with your friends? Yes or no?
Or did you like the video still? Or
Okay, let's refresh and see. No, we have 40 more likes for 15. Yes, very good.
Labia
Very good.
We'll write that. Close by.
Yeah.
Close by. If it comes here, I'll write here.
Oh yeah, no. I think we should do that.
We keep switching here and there. Ring we're playing.
Okay. The dash is a thin membrane that partially covers the vaginal opening. There's a lot of notion about this, you know, this one layer.
I spoke about it in detail in my classroom. I told them there are multiple reasons why so that dash layer can break, but
people have a very, very wrong notion about this. It is a myth, to be frank.
Exactly.
It's a superstition. It is also at some point, it is also it comes as a very big question marks to the women's out there,
True.
Because people don't know about it. People don't know the science behind it. They just know,
some random person told on the internet and they believe it.
Not even internet. I think their great grandparents told it, so they're like, okay, let me continue. Okay, next question. Very good. Hymen.
The dash is a tiny finger-like structure which lies at the upper junction of the labia minora above the urethral opening.
So where is it? On the upper junction of labia minora above the urethral opening.
So can you see, students, here we have urethral opening. In the previous we had vaginal opening. Two different openings.
Yes. I think if you know that. Yes. Anyone? Yes, very good. Janani Ravi.
Yes, and students, remember, just like the penis has erectile tissues, even the clitoris also has erectile tissues in it.
Yes.
Next question, ma'am.
Yes, please.
The cells of alveoli secrete milk which is stored in the cavities known as
Cavities. Please underline the word cavities. Cavities.
I'll become box only.
You can't call that a box. Okay.
It is a box. Okay, students, remember here, alveoli has two main functions I told you in the class. Alveoli will secrete the milk and also store the milk. Clear? Rachel is lagging.
Rachel. Lumen? Kya lumen? Why are they saying lumen?
Alveolar cavity, or we'll call it as lumen.
Okay, I thought, what is the answer for this? I thought they were in the previous one.
No.
Alveolar cavity.
Cavity or lumen. Both are correct answers. What happened?
Some glitches there.
Okay, everyone. I think it's fine now.
1 second. Yeah, you can explain, please.
That's all. So alveoli has two main functions, that is secretion of milk and also storage of milk. Why am I emphasizing on this? The reason I'm telling you more and over this question is because this was a previous question which was asked in a statement format. Right?
Okay.
I think we should tell them whenever we get PYQs also. It'll be identify them.
Several mammary ducts join to form a wider mammary which is connected to the lactiferous duct. Okay, so what is it? Mammary ducts join to form wider mammary dash. Okay, what is the answer? Which is connected to the lactiferous duct.
So when I was teaching this, and when I was teaching the chapter, I made them write a flow chart.
Okay.
Now how the milk is transferred from alveoli to mammary duct. All the ducts will fuse. They form a wider region called as.
So ampulla. I spoke. Yes, very good, ampulla. I think they might get confused with both the ampulla.
Next
Students, ampulla. Use the word ampulla. Do not use the word mammary, lobes and all that. You should use the exact word of NCERT. Okay, that is very, very important for every NEET aspirant, every board aspirant, because I told you last time also, they will have a key book, like the keywords. Okay, if that word is written ampulla and you're writing mammary lobes, they will not decode it for you, right? So that's why be careful.
Because, and here, remember, circling, so...
Yeah. OMR.
Next question, ma'am.
The primary sex organ in females are the, I think we can...
Skip this question. Very easy question. Again, ovaries. I don't know why.
Yes.
Ovaries, easy question. Next question.
I think ovaries is a favorite question.
They keep asking, ma'am. So favorite. So in females, the process of gamete formation is called as...
Yes, come on.
And students, do you want to learn oogenesis under 1 minute?
No. So do you want to learn lac operon under 1 minute? Tell
No.
yes.
So why are we telling this? Because we have recorded a video yesterday for all of you where I've explained the entire oogenesis under 1 minute and ma'am has explained the entire
lac operon under
1 minute.
You just have to watch that, students. Easily you'll be able to write answers, especially for my board students. Those who are appearing for board this time and you do not have the time to understand lac operon or read that NCERT and decode, please watch that.
But
write the explanation.
You advise you to read first somewhere or then revising.
Yeah,
This is for quick revising.
I mean, they would have watched molecular basis with me, no?
They don't know.
We are telling for students to watch our live.
Okay. So students, watch it where we have explained the entire concept in 1 minute. And if you love such concepts, right, we'll make such more videos where we explain you basic concepts or advanced concepts in 1 minute. Okay, ma'am?
Yeah.
Next question. The process that transforms spermatids, very important, spermatids into sperm is known as. Now, many students will write spermatogenesis now. Many students will write spermatogenesis. That's where you'll go wrong.
Yes.
That's where you might go wrong. It is not spermatogenesis.
Wow, we reached 90 students. Good job.
It was 94, it became 90 now.
Oh, is it? I didn't see that. So I'm happy.
Well, let's make it 100 quickly. Let's make it 100 first. So start sharing right now. Like the video, everyone. See, the more you like the video, the more it will, the reach will go. YouTube will be like, oh, some special is happening here.
Exactly. Very good.
Spermiogenesis. Exactly. It is called as spermiogenesis, not spermatogenesis. Remember. And if you have any confusion, go back to my video. I made you write a complete flow chart.
Yes. Okay. Next question. Okay. A primary spermatocyte completes the first meiotic division to form two. I remember sir's video where he told the entire flow chart. Okay.
The flow chart is very helpful, students, because when we were doing the oogenesis, I made you solve so many questions, and every single question was such a integrate.
Integrate.
I'm not saying the word. It's fine. The word is not coming. I mean, integrated equation.
Yes. Okay. That we will see it in the our live
session. I've told you the difference between spermiogenesis, spermatogenesis completely.
Yes. Okay. See, they're writing secondary spermatocytes. Very
Correct.
good.
Secondary spermatocyte.
Sir is making me do all the work, students.
Yes. Secondary spermatocyte. Now, quickly tell me in the chat, is the secondary spermatocyte haploid or diploid? Tell me first, is the secondary spermatocyte haploid or diploid? So while you answer the question, we'll go to the next question here.
Reshma, we have posted the victory mock test syllabus on our community page on the YouTube, and also we'll be posting it on Telegram. Students, whatever happens that week, that will be your syllabus, right? Yeah. That's all. Okay, so we have reproductive health, human reproduction,
That's all from our side.
That's all from our side. Then I think body fluids and circulation also have given. Yeah, body fluids and circulation, because last time I couldn't give.
Okay.
So yes. The dash cells provide nutrition to the germ cells during spermatogenesis. Haploid. Okay?
Yes, it is haploid because it is undergoing meiosis, obviously. If there is meiosis, reduction, division, haploid in nature.
Now, this one answer.
Answer this question also. I think
You too. You know, isn't it? Yes, victory mock test was free. I think now it closed.
I don't know, ma'am. I have to check.
Yeah, students, because it was till 28th, 11:59.
But
so
now we have one more surprise for you on Valentine's Day also.
Yeah, for Valentine's Day. We are giving
small surprise. If no one is giving anything, don't worry, we'll give you. If no one is giving
students. No, you don't need anyone. You need only us. Vedantu NEET English.
Exactly.
We will give you gifts.
We'll give you gifts.
Valentine's Day.
Mother's Day. Teachers' Day also we'll only give you. Children's Day we'll give you.
Yes. Okay. Yes.
Sertoli cell. Now, students, Sertoli cell is also called as nurse cell. It provides nutrition. Yes, it is also called as nurse cell.
Next
question, ma'am.
Please. Wait. The hormone that stimulates the Leydig cells and stimulates the synthesis and secretion of androgens is called as.
And students, remember, in the case of human male, the androgen here is the testosterone. And the hormone responsible for testosterone is nothing but... I'll wait for that. I'll not say. Wait.
Students, you have 13 minutes for your target. Okay? 13 minutes.
So, ma'am, when I was teaching them this hormone...
Yes, answer Pranav told first. LH.
Right, ma'am.
Luteinizing
Hormone.
hormone.
So, students, if you remember the trick I told you, the LH from L here acts on Leydig cells. Yes, Leydig cells. And FH. Yes, acts on Sertoli cell. Acts on Sertoli cells. And Leydig cells produce what? Leydig cells produce your androgen here.
Okay.
This
Next
is small
question.
thing to remember.
The acrosomes in the sperm head contains enzyme that help in dash. You can
Easy.
also tell the enzyme name and you can also tell the function. Come on.
Okay. Luteinizing hormone. Everyone is
Yeah,
talking
yeah,
full
yeah.
word. Nice.
Very. The acros. How do we have sync? Okay.
So here, students, I told you in my cell chapter also, there is one cell organelle which is present even in the acrosome head.
Yes,
That is
I
your
know.
Golgi body. Golgi body is present in your acrosome. The same Golgi body is also present in the root cap. Yes,
Yes,
fertilization.
very good, very
Yes,
good.
fertilization. Easy question, ma'am.
See, students, Sanvi attends all our live like last time I told. Regular
Yeah.
students know the exact
Because
word.
we tell you what extra points in our live classes. So if you attend the live classes where we solve live doubts all the time.
Yes. Okay.
Next question,
very good.
ma'am?
Yes, please.
Capacitation? No. Capacitation does not happen here.
The middle piece of the sperm contains dash which are necessary for the movement of
The
sperm.
sperm.
The middle piece.
So for movement, that which of movement, ma'am, you told, no? The flagellated movement, right?
Right.
So in the flagellated movement, it requires energy. The energy is derived from the powerhouse of the cell. That is the mitochondria.
What?
Mitochondria. I told properly, huh? No, yes, I told.
No, it is
Yes.
mitochondria.
No, I said mitochondria.
Mitochondria.
No, I told mitochondria.
I'll watch after the live ends you see and I will send you the
Snippet, huh?
Yeah.
I told mitochondria only, not
mitochondria.
mitochondria.
Pranav told mitochondria. isn't it?
Pranav, not me. Pranav told mitochondria.
Okay, next question.
Next question.
For normal fertility, at least % of sperm must have normal shape and size.
How much of percentage? See, no, sir. See?
That means they're telling you.
No. They're telling I didn't tell. I
That's
please
not
support
what
me,
they're trying.
Kavya.
That's not what they. Sir said correct. Oh.
See, everyone knows. You have a hearing problem.
No, I will. You see.
You have a hearing problem. It is a 60%. Exactly.
Yes, very
and
good.
out of the 60%, at least 40% should have what? 60% should have normal shape and size. 40% should have vigorous motility.
Otherwise, they're not going to reach the destination. Okay?
Car should be proper.
The process of formation of mature female gamete is called as.
Ma'am, same
process-
question, ma'am. Same question
I
as
think we
repeated. Oogenesis. It
Yes,
is
you said wrong. Who told that? Someone told. Kavya. See,
No, Kavya is deaf now. Kavya is not able to hear now.
sir,
Oogenesis. Exactly, oogenesis.
Very
Next question. The oogenesis begin at the embryonic developmental stage with a couple of million of dash cells. Now, this is a good question now, ma'am.
Yeah, it's a good
question.
I think everything related after the starting part was a very
Everything.
good question.
Now from now, it's good questions, Matt.
Come on. Speed it up.
No one is everyone writing oogenesis still, ma'am.
Wait.
Oog, someone writing
Oog. Oog. Malar, almost there but not there.
So one thing is whatever reservation you might have, always give you 100%. Always tell you. So do not be like, just because I have a reservation, can I score less? That mind should not be there, right?
Shivani, very good.
Ugon, yeah. That mindset should be not there. Even if you have a reservation, please try to score 700 plus. That should be your aim. Nothing below that. Right?
Yes. Okay, next question. The primary oocyte completes the first meiotic division. I think you're clicking something, right?
No, I'm not.
Okay, then maybe meiotic division to form a large secondary oocyte and a tiny first dash body. I would have almost told the answer. Yeah.
Now here, what type of question can be asked here is, they can give you the ploidy of secondary oocyte.
Yeah.
Yes, they can ask you ploidy of secondary oocyte.
They can ask meiotic and mitotic. They can
Interchange also, and I'll tell you.
They can ask incorrect. What is, like, you know, they can give you a set of statements. They can then ask.
They can ask you which is the
or
incorrect statement.
Yes. Yes, Vijayan, you can join. You can join. Something is wrong. Polar. Yes.
The first polar body. Now, students, remember, the first polar body is produced inside the ovary itself, but the second polar body is produced in the fallopian tube. That is very important.
Okay. Yes. Spermatogenesis begins with dash cells in the testes. Come on, tell the answer. Very good. Polar body. Correct. Next question. Ready? So slow the likes are good.
So slow, no? Everyone is very slow today. Very
Become
slow.
confused again. Conjuice. Come on, answer fast. I think we can write the answer. I think there's a chat delay, students. Yes, very
sure?
good. No, wait. Yes, spermatogonia.
Also called as your male germ cell, which later undergoes mitosis first,
Yes.
produces the
Some of
primary
them are
sperm.
told germ cells actually. Okay,
Yeah.
next question.
I think you should stop using this. Or
Yeah,
I'll be
maybe.
touching some kind of wire somewhere.
No, not actually. We're not even near the wire.
Yeah, not touching.
I think we will just do
Ah.
next. But it's too. Okay.
Ah.
Fine. 9. Oh, I think it's a board thing.
Okay. The primary spermatocyte completes the first meiotic division to form 2 dash spermatocyte.
Yes.
It is the easy question from secondary spermatocyte. So your first meiotic division from your primary spermatocyte, you get secondary spermatocyte.
Students, explanation is not required, so that's why we're waiting for your answers, because we have done the chapter. If it's a chapter which we have not done, we will give you explanation. Okay?
Yes.
The menstrual flow occurs and lasts for dash days. Come on, how many days?
The menstruation flow lasts for dash days. Now this is
This
very
is a very, I think, we cannot spread. I mean, according to textbook, we can write a number, but otherwise, we cannot really say this
usually
number.
I've heard even in some cases.
Yeah, it goes even to 16 days. Yes, there
I've
are
heard
people.
it goes to even some cases even
30
20 days.
the
Yeah,
entire
entire month. Entire month periods will be there, right? Entire
because
month.
of all this PCOD,
Real.
PCOS and all that. No? Yeah,
Right.
next question. The release of secondary
The
oocyte from the ovary by the process is called as. Students, what's the question? The release of secondary oocyte. Okay? Weekly mock test happens from 2 to 5.
2 to
Okay?
5.
Student, link is there. How are you not able to get the link? Okay, do not worry. Join us on Vedantu NEET English Telegram. We will share you the link.
Yeah,
Okay?
we'll share the
do
link
not worry. Yes, very good. What's the answer? Ovulation.
And it happens which day, ma'am?
14th
day when the LH, luteinizing hormone, is at peak. Called as LH surge.
Yes.
Okay.
Next question, sir. Please read.
The breakdown of the endometrium lining during the menstrual flow results due to the withdrawal of dash and dash hormones.
Come on, answer this. We will wait for your answers.
Yeah. Now
It's a very
here,
good question.
Very good question. Very good question.
I think actually this. Okay, I think there's a. Yeah. This same what do you tell? Technique is used for making pills also.
Yes.
Pills also.
Based on
hormonal-
this, on this.
hormonal implants, everything is works on this itself.
Exactly.
Come on, who is this telling the answer? Students, quick, increase the speed.
Progesterone and estrogen. Progesterone and estrogen. And remember, progesterone is maintained by corpus luteum. And if there is, decrease in LH, your corpus luteum starts to degenerate, and progesterone also is decreased. Clear?
Next one.
Small concept we're teaching middle. The dash phase.
Okay, we'll come.
The dash phase of menstrual cycle is when the primary follicle grows to become fully mature Graafian follicle.
Very good.
Which phase?
Which phase?
The dash phase of the menstrual cycle is when the primary follicle grows to become fully mature Graafian follicle.
Come on, tell the answer quickly. Students, speed has to little.
And also tell me which is the hormone responsible for the. I'll wait for the answer. Yes, follicular phase.
Very good,
Now
very
tell me quickly in the chat which hormone is responsible for growth of the follicles. Yes,
Next. Yes, next question.
increase in FSH, follicle stimulating hormone. If they don't tell, dumb kids.
Ovulation typically occurs around
Easy question.
dash day. Yeah, we just asked.
14th day of the menstrual cycle.
Okay, students, I don't know what is.
Should I call Mithun?
Yeah, maybe I think.
I don't know. It's fine. Let's.
Okay.
Here.
After ovulation, the corpus luteum forms and secretes mainly
Mainly.
dash.
This is a NEET PYQ, ma'am.
Yeah, this is a
right here
NEET.
NEET PYQ.
Yes, yes.
This is a
All questions with hormones can come for NEET.
Exactly.
Because that is the place where they can trick you. Otherwise, they
And
have to trick you.
even in the follicular phase, right, when we have the dominant follicle, once we get the graphene follicle, the level of FSH starts to reduce. Now that is because of the inhibin. That also is a NEET PYQ for all of you.
Yes,
Okay.
very good. Progesterone.
Corpus produces progesterone.
I lost track.
Sorry, I disturbed you.
yeah. I'm writing a spelling and you stop me.
Uh,
Okay.
the luteal phase is also known as the dash phase of the menstrual cycle.
The luteal phase is also called as the
You already told. So students, remember the luteal phase happens in the ovary, while similar event is happening in the uterus. The event which is happening in the uterus at the same time is nothing but, should I wait for the answer? Yes, I'm waiting for the answer, ma'am. Secretory phase, exactly. Secretory phase.
Yes, good job, good job. Not follicular phase, secretory phase. A lack of menstruation, you can only write that.
Okay,
May be indicative of dash if the released ovum is fertilized. Come on, what a easy question. I think everyone knows this.
Yeah.
Students, we are going to reach 1 minute to 7:15 and likes have not reached 300.
Just check my once.
Okay, let's refresh. Let's have high hopes on students. They usually
Yes,
never
it's
break my hopes.
pregnancy. Yes.
Let's see. No, they broke. It's 287.
87. 13 more, no?
They didn't do it.
They didn't do it.
Students, your target was 300 likes before 7:15. Come on, try doing it.
After ovulation, the dash phase occurs during which the corpus luteum is formed.
This is important. These phases are important. Follicular, secretory,
Luteal
dash.
phase. Dash phase. I didn't say anything. Dash phase.
Yes. Tell the answer. Very good.
It's the luteal phase. Now, all of these phases are extremely important because that's where the question will come from.
Nirmal, very good. Very good. Good answer.
No.
What happened?
No. I just saw it. Next question.
Okay, the released ovum is not fertilized. The dash phase begins marking a new cycle. New cycle.
87th. Amazing.
Virat is telling mine is the 287th like. Come on, make it. Who is going to be the 300th like? So it's 300th like.
300th like.
Okay, very good. What's the answer? Menstruation. Yeah. Here,
No, they're not telling, ma'am.
No, see here. See.
No.
Subhashni told, Malar told.
Oh, they're telling.
See,
Not
there
bad.
it's not loading.
Ma'am, it is going. Menstrual phase. Next question.
Menstrual cycle ceases around 50 years of age. This is known as. Pause kar do.
What?
Body will tell.
Pause. I'm telling you what I thought you're telling it to the chat. Pause kar do. Oh god.
Come on.
You know, when I was in class 5th, I guess, I could not read pause. Like pause.
Pause. French.
Well, no, but yeah. That,
we say pause.
No, I'm like pause. I couldn't read it properly. And that time, I used to tell my mama like, Mama, can you pause the video, pause the song. It's pause.
Apple. Just to his étudiant. French.
You do French class, so?
Yeah. Even German.
Why French and German?
English was boring at one
Only
point.
thing we ever had was Sanskrit. Sanskrit was till class 8. Sanskrit was compulsory.
I can only say Jamapple, Gopika. Je suis étudiant.
My name is.
My name is.
I remember Joey.
Como tu tavada. Something.
A sperm comes in contact with the dash layer of the ovum and induces a change in the membrane that blocks the entry of additional sperms. So this is important.
Big
Very
question.
important. Now this is a PYQ again.
Which layer?
Which layer?
Yes. Next question.
And remember, the same layer is present on the in your morula. When the blastocyst, when the morula stage, the zona pleural, the dash layer is present on.
You've been telling answers.
No.
You're
I'm
out
helping
of this class.
Yes, I saw the answer there.
No.
Zona pellucida.
No.
And remember, students, I told you in my live class, the reason morula cannot attach to the endometrium layer is because the zona pellucida layer is still present. Once the zona pellucida layer breaks, once the cyst is broken, we get the blastocyst, and blastocyst can attach to the endometrium layer.
Can we give one clap for our students?
Yeah.
Please.
Okay.
Huh?
Listening to so much.
No.
Yeah.
They made
300. Oh, they made 300. Okay.
Made 302.
302.
I told you, they never break our hearts.
Okay.
They care more than anyone in our.
The dash begins as the zygote moves towards the isthmus of oviduct called as cleavage towards the uterus.
Oh my God, what's the answer?
Which type of division?
Kavya, yes, 303. Sir keeps telling answers. Shall I remove sir from the live, students? You please tell me. Put red hearts and remove sir from the live.
Put green hearts if you want me to stay. Put green hearts in the chat if you want me to stay. What is this?
He keeps telling the answers. They don't have time. They're like, we don't have time to laugh for your jokes. We'll laugh at the end for everything together. They didn't comment, last time when we asked them to do it for the bio session. We're disappointed.
If I see red hearts, no, I'll go mad.
That's not a greener, that's a peacock.
Peacock
okay?
is there.
No. Yes, very good.
Oh my God. Then Nancy is angry at me. Oh my God. Kavya is like, should we remove, should we not remove? Should we remove, should we not remove, Kavya?
Vivek is like, I'm neutral. My blue deoxygenated blood is going around. What is it?
It's the mitotic division. See, green hearts. Thank God. Otherwise, ma'am was ready to kick me out here. Next one.
Okay. The embryo within the 8 to 16 cells is called as 8 to 16 cells.
It's called as. Now, this again is a P/Q. Now, students, if I remember correctly, this question was asked in a statement-based question where they give you a couple of statements, and one of the statements was this. So, Gautam is telling it happens in the ampular isthmus region. That was in your old NCERT. Now it's only ampular, not ampular isthmus region. Don't be like, sir, old NCERT. It's very old. When we were studying.
Yeah.
When we were studying, it was ampular isthmus region. Now it is just.
Yes, come on.
Morula. Yes.
Morula. Yes. Next question.
Next question.
Ready? Okay. The morula continues to divide and transform into. So morula.
The cyst is broken. The zona pellucida layer is completely broken up, and we get a cyst. We get a cyst called as.
No, they'll tell that.
Then we got a cyst called as.
Morula.
Everyone is so slow. Ma'am, likes you just check, ma'am. Attendance you check, man.
303 itself. They're stuck in 303. Blastomeres are the cells. Tell us the cyst. Cyst. Very good. Who was that? Mona.
What?
Mona. I can't pronounce her name, so I keep calling her Mona. Mona.
Next question.
Blastocyst.
The trophoblast later gets attached to the endometrium, and this process is known as.
Very important. Very important.
Now, students, remember the blast.
No. Continue.
The blastocyst has two types of cells, right? In the blastocyst, the blastomeres arrange in two parts. One towards the periphery, that is your trophoblast.
Yes.
And inner one is called as inner cell mass. So,
yes.
Implantation.
I can still not pronounce her name.
Nirmala.
No.
Okay, we'll see. Implantation. Students, did you notice we are actually covering the entire chapter?
Yes.
Like the entire flow we went.
Yeah.
First we did the,
starting part.
Male and female reproductive structures. Then we went to the spermatogenesis.
Now we are into the pregnancy, hormones, menstruation, graphene, follicle, corpus luteum, all this. Okay? Yes. Next question.
Next question.
After implantation, finger-like projections are called as dash that appear in the trophoblast. Trophoblast. Come on. Tell.
I'm like, what is non-depleting?
Yes, correct. Inner cell mass contains stem cells.
Which are actually a type of your totipotent cells which can give rise to any organ.
Yes.
Say the name, ma'am. Before you get the
Microvilli, but what villi exactly?
chorionic villi, not.
Yes, very good. Janani, very good. Sanvi, very good. Malar, very good. Okay. Yes.
Chorionic
Villi.
Now remember the same chorionic villi which gets interdigitated with the uteral tissues, which forms dash. That is the next question for all of you.
So sad. They're difficultly typing this. You want to give them
Yeah,
more
yeah.
questions.
Question is, students, remember the chorionic villi gets interdigitated with uteral tissues, forms a separate structure called as dash. That is a PYQ, ma'am. That is a PYQ like that.
Okay.
I'll read,
Okay.
ma'am.
Okay.
The fully developed fetal ejection reflex starts with the induction by a complex neuroendocrine mechanism, and the signals for the parturition originates from a fully developed fetus and the dash. Ma'am, the question which I asked and this answer is same.
Very good.
The question, no, they're answering for that one actually.
But it's okay.
Oh, it's okay. The same answer is for here. The same answer is here.
So students understood. You can frame it two ways.
ways.
The way sir asked,
That's
the way it is in the textbook.
And they can also ask you a question like which is a temporary endocrine gland.
Yeah, that also they can ask.
They can ask you which is a temporary endocrine gland from chemical coordination to this connection chapter, right?
Actually, chemical coordination everywhere here and there, little
connection is there.
Yeah. It's like, they took the chemical coordination and they sprinkled like this in all the chapters.
All together.
Okay, next question.
Placenta.
Vigorous contraction of the uterus at the end of the pregnancy causes expulsion or the delivery of the fetus, a process called as. Okay.
Say the name, no?
Rukshita.
Rukshita.
M. Rukshita. We told your name. Happy?
No, she'll say.
Okay, answer.
They didn't tell, no, still.
Wait, why did it go? Yeah.
Someone is lagging, I guess. Yes, Nirmal.
Yes,
Nirmal
yes.
is on point today. Nirmal is killing it today, full on.
Yes.
Everyone, all of you clap for Nirmal because I've been
Nirmal,
seeing.
Rukshita, Malar, Desiti.
No, everyone wants. I will let everyone clap for Nirmal because he's been answering like, continuously, full on.
You're telling, no, that is the clap actually. Wait.
It's going and coming.
We should let them know. But
Hmm.
the morula continues to divide and transform into.
Again,
Students? No, that time it was blastocyst.
Blastocyst.
Okay, come on now, tell us the stage. Morula develops into dash, that develops into dash, and it continues. I think the last stage is not given, no?
No.
Gastrula is not given.
Not given. Actually, even blastula.
Yes, you are also killing it, Pranav.
Pranav was killing it. Yes.
All our students are killing it, okay? Yes, definitely.
Everyone is killing it.
Tanvi, Subhashni.
I saw Tanvi also answering very quickly, and Pranav also.
Subhashni also is answering.
Subhashni
very
also is
quickly.
answering.
Okay.
Nitya also I saw.
Yeah.
Tropoblast.
Now Rukshita is answering after we told her name. She wanted that power.
Yeah. That
Rukshita.
extra motivation.
Get on, right? Yes. Students, we are here to do that for you. You can consider us like your elder ones, like your elder sister, like your elder brother, and let us know when you're facing a problem. See, not every time we can be
Mona,
like,
yes. Sorry.
okay, not every time we can be replying or responding, but then definitely if there is a point where you feel like, no, I need to talk to ma'am, you can definitely make a way. You can let us know in the Telegram comments that, ma'am, I want to talk to you, I'm facing this issue, or sir, I want to talk to you, I'm facing this issue.
Students, trust me, we always, just like your elder brother, elder sister,
We always check.
always check on you if you have studying, if you're completing a syllabus, always, we come and check on you. Okay?
Right? Yes.
Yeah. The outer layer called the dash layer cells and an inner group of cells attached to the tropoblast called as inner. Easy question, ma'am. Easy question.
They still, yes. Come on, tell the answer.
I think there's a missing line here, ma'am. The outer layer is called the dash. The tropoblast layer, they are talking about this. Then they're asking you cells also inside. So
I think we can just answer. Okay, yeah. We can tell the cells, students, and then
the outer area is the trophoblast. But the cells, can you see the cells here? That is blastomere, right? They're asking, tell you blastomere also. Next question, ma'am. I'm looking it now. Exactly.
Okay, yes. The trophoblast later gets attached to the endometrium, and this process
I
is
think-
known as.
Different question, ma'am, again. See,
Yeah.
you see the frame is again different.
Yeah, different question. Framing is different.
Okay. That is implantation. Clear?
Yes. Students, join us on Vedantu NEET English Telegram. There you have an option to type your comments and you can tag
Everything.
us and
Yeah.
we will be able to see. After implantation, finger-like projections called dash appear on the trophoblast. I think,
Colonic will I cerebral question.
Students, this is the reason we are not targeting the 100 or 200 questions because we want selected questions. We want
And,
filtered question. Okay.
Remember, we just finished one. We are finishing one chapter. We have one more chapter after this.
Yes.
Remember that.
Okay. In the later phase of pregnancy, a hormone called dash is also secreted by the ovary.
The spoiler
Also-
alert, it is not estrogen, it is not progesterone, something else. Something else.
Yes.
How to call Telegram channel? Telegram, you can always go to the NEET English Telegram channel. Contact there, just type a message and we will reply to it personally. And also, if you want to talk to us, personally, we'll be coming live on the Telegram where you
Our
can
own personal
telegrams where you can talk to us. And don't
Biology
worry,
by Gopika.
even if it is Gopika on Telegram, I'll be there hijacking it. I'll be there in the back in the corner peeping.
Yes, very good. Relaxin.
Yes.
Relaxin. Okay. No, relaxin, not oxytocin. Relaxin.
Remember, oxytocin is produced by
No,
hypothalamus.
yeah.
Ah.
I mean, it's a love hormone. It's, for other, vasopressin and oxytocin. The dash soon appears between the ectoderm and the endoderm, and these three layers give rise to the tissues in the adults. What are the three layers? Okay.
Please say the name.
Which one? Who? No, she's also a regular student.
I know.
Desiti.
Desiti, I know.
Yeah, Desiti.
I've seen that. Yes, mesoderm.
Yeah, very nice name. No?
Yeah.
I can't pronounce it, but that's the only problem.
The funny part is, Gopika ma'am, even name will pronounce. My name still so many people cannot pronounce.
Yeah, my name is easy. to
Easy,
pronounce.
Gopika
Yeah.
ma'am.
I know the students who regularly attend my live. No, I keep seeing their names.
Did you have trouble pronouncing my name in the starting, in the college time?
No.
No?
But maybe North Indian names are very, easy for me.
Northern names are very easy. The
Yeah,
proper
bendable.
South Indian names are like, traditional.
Students' tongue becomes flexible sometimes. Yeah, next question. By the end of dash weeks of pregnancy, the fetus is fully developed and it is ready for delivery. I can write it easily here, no? Yes. Mesoderm.
Yes. And even...
It hurts. It's hurt. That's my word. I keep using that word. Then what was the question?
Students, again, I'll ask one more question here. At which month do you observe the first heartbeat? That is one question. The next question here, which can be asked, is at which month the limbs and the separation of eyelid is happening? That can be a separate question. The other question can be at which month there is the fetal movement? That can be a separate question. So every single line of that one paragraph of your NCERT can be asked as a separate question altogether. Okay?
Why can't I see Sharat answering?
Sleeping.
No. Okay. I think we didn't.
Huh.
Okay, next one. The government of India took various steps
From here it starts.
Oh, yes.
Okay.
Students, we are starting reproductive health.
now.
Okay.
If you want us to stop here, or you want me to continue, tell
Even
us in
if
the
you
chat.
tell us to stop, we
We'll
won't
not
stop.
stop. Let us get them give them.
Okay.
Now,
Okay.
students,
If they want to stop, let them put green hearts, and if they want to start, let them put red hearts. Okay. Okay. Come on, students. If you want us to
massacring the
stop
green
here,
hearts.
if you want to stop here, put green heart, and if you want to
you're doing the
continue,
opposite because signal red is stop, na.
blood
If
flows
you
red color.
so if you want us to
Oxygenated.
stop, red hearts, because gaadis will stop if you put red hearts. If you want us to continue, put green hearts. Green hearts to continue.
So difficult to tell. They're telling the answer. See, they don't want to start.
Yes.
They're typing red heart. No time, ma'am. Red heart.
Okay, the government of India took various steps to create awareness among the people about the reproductive related aspects. The programs called as family planning were initiated in the year 1951. Very important. They put red hearts up. They got confused actually.
That's what I'm telling.
Ah.
They're using brains.
See, I told you.
That's the problem. That's why you can see that green came, red came.
Okay.
Okay. A ban. What did I? Okay, never
That's
mind.
fine. So the statutory ban on dash has been one of the effective measures taken by the Indian government.
Yes, tell. Ban is done because they were using this to identify, or sex determination was done because of this, and they were they were doing female feticides where they were like, okay, why to give dowry, why to educate the woman, or why to
All the
educate the child.
wrongdoings, no?
Yes.
Just amino synthesis. Finally said it.
Amniocentesis.
This is. Next question, ma'am.
Yes, please. Improved program covering wider reproduction related areas are currently in operation under the popular name. That means we could say the program that was started by one among most of the countries. India also was there to start this first. So what's the program name? Come on, students, tell the program name.
Ma'am, please tell ma'am today what chapters, only 2 chapters, that is human reproduction as well as reproductive health.
The chapter which we did this week. Okay, that chapter, sorry. Okay, please write popular name. Very good. RCH or reproductive and child welfare. No, healthcare. I keep saying welfare, it's easy. Okay, yes. Next
question.
An important decline in death rate and an increase in the number of people in the reproductive age are probably the reason for increase in population or growth of our population. Okay, students, what is the answer for this? Remember, I told you about, I don't know what you call them. Is it,
103. 101.
No, this, what is this? I was trying to.
I'm ready to forget now.
Yeah. I don't know. You remember those old ladies used to come and take deliveries in old movies? They're called the midwives, I guess.
Okay.
They used to come, older ladies used to come and they used
I am blank.
Forget it. MMR, very good.
Yes.
Maternal mortality rate.
Mortality rate.
He switched my brain off and he switched his brain also off. Yes?
One of the methods to track this problem.
Tackle this problem.
Ma'am, the light is reflecting there. One of the methods to tackle this problem includes the usage of dash methods like condoms and oral contraceptive, injectables, implants, and surgical methods.
What's the answer?
It is the opposite of seption.
My God.
English.
Let my students survive.
It is the opposite of seption. Seption means
no one
act
cares.
of getting pregnant.
No one
Opposite of seption is contraception.
Malar is crying there after typing that answer.
Contraception, opposite of seption. English, that's how you remember things. You connect things and.
You think they have time after studying 200 chapters? They have time to tell or conception, opposite of conception, contraception.
Now you will remember. Opposite of conception is contraception. Remember it like that.
They will remember my face expression to your joke.
Very funny. Dash methods such as rhythmic rhythm or pull out method also advised alongside modern contraceptive methods.
My God, such a big word. Yes, tell the answer. Dash methods such as the rhythm, pull out, withdrawal, coitus, interruptus, all this are what kind of a method? What kind of a method?
All of these are artificial or dash? Opposite of artificial is what? Opposite of artificial is?
Okay, students put C.
See, everyone will remember now.
Only one student told I will remember.
Everyone will remember.
They're just not making you feel bad, that's all.
No, they'll remember. It's called a natural, opposite of artificial. Natural methods or traditional methods.
Did you say artificial opposite of natural? And I was thinking, I can't, yeah.
Periodic abstinence is one such method in which couples avoid or plan coitus from the day dash to the day of the menstrual cycle.
Students, number. Just tell the number.
Number, yeah.
I'm always dominating. Yeah. Very innocent students. Very innocent. Today, just born.
Just 10 to 17,
I
exactly.
know him from past 5 years.
5 to 6 years. No, wait. I don't know. 5 years, I guess.
5
5 years.
I know sir from 5 years, and you're telling me he's innocent.
But the funny part was we hardly spoke in college, right?
Yeah.
I thought she was full attitude, no? So that's why.
Same. Okay, 10 to 17. Very good. Dash is another method in which the male partner withdraws his penis from the vagina just before ejaculation.
Full rhythm, no?
Full-
Ah.
Nothing is there, but rhythm is there. Thank you, Rukshita.
Bacillus, sir.
Beauty.
Okay, I am losing my eyesight. Beauty is I am seeing bacillus. I don't know why. Because I was
Sir sees himself as a rod-shaped bacteria.
Bacillus.
What is the question?
That is
Yeah,
withdrawal
withdrawal.
method. Withdrawal method. Withdrawal or coitus interruptus. Withdrawal or coitus interruptus. Why are you laughing? Next question. Dash venerea method is based on the fact that the ovulation and therefore the cycle do not occur during the period of intense lactation following the parturition.
Yes. Since what's the answer? The answer is there. No problem, no problem. Just type whatever you are able to type.
Yeah. Spectacles. I have a spectacle. Some of you might see my class where I take spectacles, right? Because sometimes I can't read what is. See, the thing is, it's very far. The child is very far, and if I try to focus in like this, very difficult to read. So,
Lactational amenorrhea is what? That means you can avoid the pregnancy when the mother is feeding, right? For that 6 months.
avoidception.
Teach.
In Marian method, the ovum and sperm are prevented from physically meeting with the help of dash. Now, this is actually the difference between your IUD, valves, physical meeting. No?
They're calling you Gajini.
Gajini doesn't have short-term memory. I have good memory. Come on, I'm a botanist. I used to remember 54 families. No, I don't remember it now, but I used to remember 54 plant families, every single detail. Like
Things are making me laugh so much. I
just
can't.
don't spit water on me. That's all. Okay.
Very good. Barriers.
Or condoms. Clear?
Yeah, our NEET students have good humor sense, no?
Yeah.
They're very sharp when it comes to some things.
The
Okay.
most, this is the question I was telling, ma'am.
Yeah.
The most widely accepted method of contraception in India is the use of dash.
This is actually shocking.
You don't tell it, I'll keep it hidden.
Bro, they are full
Okay.
Instagrammers. No, actually, when the students were recorded, they'll be like, why are the two teachers just
laughing so much.
Because they wouldn't
See,
see
students,
this, no.
if you're watching it recorded, come to live. That's what we'll say. If you're watching it recorded, trust me, the live is more fun. The live, you can actually ask any kind of doubt. We'll respond to the doubt then and there. Right? IUDs.
Yes. Okay.
The oral administration of small dosage of either progesterone or dash estrogen.
I think that, no.
It's combination.
Okay.
So, the oral administration of small dosage of either progesterone or dash estrogen combinations is another contraceptive method used by the females.
Students, remember, we don't mini pills. Okay? Mini pills. Yeah, Shweta is taking very personally. Sir is not at all feeling. Students, when you tell us some like small cute things, so we take it as very cute things only, okay? Right? Yes, we do not take it very hard
That is
to us.
progesterone and estrogen combination.
Yes, so students, I'm writing P and E, okay? I don't want to write the whole. Yes, okay, next one. Surgical methods, also called as dash, are generally advised for the male and the female partners as a terminal method to prevent any more pregnancies. That means once they have completely built their family, okay, they've done their family
more
planning.
addition.
Yeah, no more
Addition.
addition. That time they use this method. Remember? Yes. Tell the answer. Yes, correct. Sterilization. Or your vasectomy and tubectomy. So I like sterilization.
See, the reason ma'am is not writing vasectomy or tubectomy because the question mentions as male/female. If it was only male, it would have
Yeah.
been vasectomy.
Yes.
Only female, tubectomy. But right now, it is both.
Yes, yes.
Next one.
The medical termination of pregnancy. How what?
Thank you so
The
much.
Medical Termination of Pregnancy (MTP) Act was was enacted by the government of India within the intention of reducing the incidence of illegal abortion and consequent material mortality and, oh my god, such a big question, students. Just tell the year.
You also want water?
No, it's fine. Students, just tell the year when the amendment was passed. Okay. Yeah, 1971 is when the MTP was, passed, but then 2017 was when the amendment came.
Amendment is implementation.
Yes,
When the
yes.
implementation happened was 2017 was the implementation. Remember
Actually,
that.
it was because government was still deciding is it okay to do MTP, because MTP started because of rape cases when
Yeah.
unwanted pregnancies happened because of rape. But then people started taking
Misuse
it
it.
advantage.
Misuse
Yeah,
of
they were
it.
like, okay, we are not ready to be parents, so let's just abort. Or this was it was not planned. I'm not planned yet. I don't have the financial stability. That time they brought about. Okay.
And remember, it was legalized also for some reasons. Wanted legalized because of genetic disorders.
Yes. Yes.
Yes. Recently, also I saw one of such message in Supreme Court something. But I don't remember it now. Dash are the barrier methods made up of rubber that are inserted into the female reproductive tract to cover the cervix during the coitus.
Yes. Yes, students, it is 2017. You can check in your NCERT. Okay, it is given 2017. Okay. Next question, please answer. Exactly. Our students are faster than us, no doubt. Okay.
Yes, started in 1970.
Amendment in
2017.
Easy, no? 71, 17.
Ulta.
Yes. No, students, think of the other ones. Think of the other one. 3 names are given, no? 3 names are given other than the condoms. That's the question, right?
Yes. Correct.
Yeah.
The three other names.
Three other things. Who is going to
Apart
tell?
from the
Yes, very
cervical
good.
caps. Yes.
Cervical cap.
Cervical caps, walls, as well as diaphragm.
Okay,
diaphragm. Cervical caps and walls. Yes. Correct. Nice. You're writing it, Nella. Smart.
I am. The new oral contraceptives for the female, Saheli, contains a non-steroidal preparation and it is taken once in dash. Okay, so Saheli was started, it was found by Dr. Nityanand, okay, and he passed away when he was 99. He did it when in Lucknow.
Okay.
CDRI.
That is a question again. NEET question.
Yeah.
So they changed Lucknow to Delhi, and that was a question, if I remember correctly.
They will do that,
Week, exactly. Once a week.
Yes, once a week. Very
See,
good.
students, we are not only just having fun, we are telling you how the question can be framed also. This question can be asked. Saheli questions have been asked, right? And they'll ask you which institute it was,
done and who did it. Even though it is not an NCERT, sometimes they expect the students to have a little more knowledge. Because when we were all preparing for NEET, we used to have a lot of knowledge. That means we used to have so many reference book to revise from. So from that we have reduced to only NCERT, so they might expect the teacher at least to tell it. So that's why we have mentioned
the reason I told you about Hinnabin also was it is out of NCERT, but question has been asked. That is 2016. It came 2016, ma'am.
That's what. Okay. Sterilization in males is also called dash, which involves cutting and tying
Easy
of
question,
the
ma'am.
vasa deferens. Okay. Yes. Correct. Yes, very good. Vasectomy, very fast.
They told, huh?
Yes. Drama queen. Vasectomy.
Next question.
Yes, please. Next question.
In
Let's see.
females, the sterilization can be performed through a procedure known as dash, which involves blocking or cutting of the fallopian tube.
Okay. In females, sterilization can be performed. Yes, students, tell me. Yes, very good. Tubectomy.
Tubectomy already told. No one told, ma'am.
See the phone.
No. Now it came.
It's okay, tubectomy.
Dharmesh. Yes, we have cockroach and frog. Correct.
Yes, both cockroach and frog, because NMC told insect. So they had to correct it with the help of cockroach. The Dash Act permits induced abortion under certain conditions to safeguard the health of the mother. That means, what is that whole thing? Okay. Yes, tubectomy.
Tumectomy, correct. I
Yes,
understand.
MTP.
MTP. That is medically termination of pregnancy. That is under certain conditions, MT.
Yeah, I think the next question comes about the weeks. MTP can be legally performed up to -weeks of gestation under specialized conditions. Tell the time period when MTP is actually, safe to do, even though people, do it after 2-3 weeks and all. But then what is a safe period? What is a safe time? Come on, quick.
Come on, where is the answers?
Students, for short forms, please write the short forms, okay? Don't waste your time typing the whole
entire
thing.
thing.
Okay, we totally understand that you people know the answer. Okay, very
12
good.
weeks.
12 weeks. They say 12 to 20 weeks, but
12,
then
12.
even 20 weeks is
Too
not,
much.
it's not,
Methods like dash are suggested to avoid indiscriminate and illegal female feticide.
I think this we already did.
A minus
I
it.
made notes.
Let's go to expression.
Okay, please.
The emergency contraceptive can be taken within the dash hours of unprotected intercourse to prevent the pregnancy.
Very important. Hours are very, very important.
This is just the IPL, right? This is for the IPL, I guess.
This is, for the
IPL.
Yeah. Yes, come on, answer. What is the time period within which they have to take an emergency contraceptive to avoid pregnancy? Okay? Yes, very
Exactly.
good.
72 hours.
72 hours. No, you don't.
Yeah.
Next question. Infection. Okay.
Infections or diseases which are transmitted through sexual intercourse are collectively called as sexually transmitted diseases, STI or dash.
This is a ditto sentence from NCERT. Yeah, same to same. Same to same. Let's see who's going to answer. No, here also it's not there, no?
Let me check. VD, yes.
Very good.
That is venereal diseases. We just write VD.
Sorry, I wrote the whole thing.
Venereal diseases.
Or reproductive tract infection, RTI.
RTI.
The most discussed STI in the recent years, and dash is also the common STIs. I have done an entire video on this.
That's AIDS. AIDS is caused by.
Yeah, AIDS is caused by. Yes.
Different the question.
Exactly, students. Lot of questions can come from them because they're studying it in human health and diseases. They can also give it in reproductive health.
True.
That's the reason, sometimes when questions are given, when they say 12 marks, sometimes it also drops to 16 marks. That's the main reason, because most chapters are interconnected. Yes, very good. AIDS or HIV, right? HIV. Yes. Next question. Dash technologies include all the fertility treatments in which both the eggs and sperms are handled. That means the entire, other than adoption. Other than adoption, what is the other method that a couple wants to have their own baby? What is the other method?
Ma'am, the answer is given here only.
Oh no, they don't know the full form.
Tell the full form.
Students, you don't write R.
What is A and R here?
Yes, tell what is A
in
and R.
art, what is A and R?
Did you scratch on that? Yes.
What is A and R?
They're telling the methods. Yes, very good. Assisted reproductive.
Yes.
Dr. Sid and Muller. Who else have answered? Nirmal, no?
Nirma also answered, I guess. IVF? No, not IVF. Art. Assisted reproductive technologies.
Next one. In vitro fertilization, IVF, is followed by an embryo transfer or dash into the uterus of the female. So after IVF, we have your embryo transfer. And embryo transfer can be of two types. Okay, this is your question, and you can have IUTs. Right? IUT is a question?
No. Other one is question.
That's question.
Now here there was a NEET PYQ. The answer here, right? Whatever answer you have, is this a type of IVF? That was the question, ma'am. Like a statement-based question they had. Is whatever answer here, is it a type of IVF?
And this chapter, they will completely hold on full form.
Full form. Entire
Because
full
most
form
of the students will get confused.
here.
Zipped very good.
Yes. That is gamete intrafallopian.
No, it's zygote.
Sorry, zygote intrafallopian transfer.
Next question. That is
Dash.
also confusing. Gamete, gift and zip.
Zipped.
Dash is another method attempted to form an embryo, further development inside a specialized procedure. It's basically they're talking about when the
Lab condition.
outside the female body and inside the female. So
body.
here they're asking inside the
of-
female body, what is that
What
condition
condition
called?
called?
Is it in vitro or in vivo?
See, in vivo.
I say in vivo.
In vivo.
Vivo. In vivo also is correct.
Huh,
Both are correct.
Both are correct.
We are
Differences, no?
British and
In
American.
vivo and in vivo.
You're British.
Intracytoplasmic sperm injection (ICSI) is a sperm is directly injected into the dash.
Answer is there in the question.
Yes.
Yes. In correct. Next question, students.
Next question.
Very good. Cytoplasm.
Plasm. Question. Actually, when I was teaching this chapter once, I had the GIF for this. Like, you know, the sperm will inject into the infertility cases either due to the incapability of the male partner to inseminate the female or due to the very low sperm count in the ejaculates could be corrected by dash.
Yes,
Basically,
correct.
after opposite of natural,
Yeah.
opposite of natural,
AI.
AI, artificial intelligence.
Artificial
Intelligence. Artificial insemination.
Yes, very good. Okay,
Yes.
next question. Infertility due to a very low dash in the ejaculates could be corrected by dash. So I was telling them about this theory also, where the mother-in-law tells, मेरे son को कुछ problem नहीं होता.
तुम्हारा ही problem है.
तुम्हारा ही problem है.
गलत निकलो.
So I was telling them this to remember the examples when the sperm count is low. Almost no
They never
sperm.
consider that actually. They might problem with the guy.
Yeah,
Never
they can
consider.
never think about it because you know the main
Male
concept
ego.
is
Male ego will
that
stand
is
in
also
the.
there. And also they think that sperms are being produced entire lifetime. Why cannot?
Low sperm count and
Yeah, low
sperm count and intrauterine insemination. IUI.
Next one.
Assisted reproductive techniques includes all fertility treatments in which both dash and dash are handled. I think this was easy question.
Yeah, I think next one.
Against sperm. Very easy question.
Students, if you're new to this channel, do not forget to subscribe to the channel. Just because we didn't tell you, do not be like ma'am didn't tell me not to subscribe, so I'm not going to subscribe. Okay,
Because
please do
ma'am
subscribe.
if ma'am doesn't like the video, you won't like the video also, no?
Yeah, they don't do.
Dash are usually used along with these barriers to increase their contraceptive efficiency.
Very good question. Come on.
Contraceptive efficiency, that is, they are against conception. They're against conception. So along with the condoms, there are other, amenities which are used. Fancy English. Other amenities which are used. Yeah. No, not. Yes. Spermicidal creams.
Very good.
Yes. Spermicidal creams, jellies, and foams.
Yeah, I wrote off the whole.
This side, no? Short form.
Yeah, creams, jellies,
Leaves and foams. Clear? And foams.
Next question. We have to call Diksha ma'am, no?
How many questions are there, no?
We are 98. We are in the 99th question.
You can call Diksha ma'am, I'll be discussing.
Yes.
Dash method is based on the fact that ovulation and therefore the cycle do not occur during the period of intake. There would be no pregnancy. Lactational amenorrhea, yes. LA, I'll write. LA. There's no space to write. So, lactational amenorrhea. Clear? Now, let's go to the next question. Examples of IODs. Quickly tell me examples of IODs now. All of you. Quickly tell me the examples of different types of IODs. See, the first example is a copper releasing one. That is your copper T. Yes, copper releasing one, which is a copper T. How does the copper T function? Copper T completely retards the movement of the sperm. Then we have the copper 7. What happened? Then we have multi-load 375. Yes. Multi-load 375.
Yes.
Yes,
Non-medicated. Yes, non-medicated is there. Hormonal is there. Yes. CUT, CU7. We have this one. right?
Yeah, that's all. So we'll bring them on the screen, ma'am. We'll tell them where to find things.
Yeah.
Otherwise, they'll forget it all.
Students, by the way, tomorrow there's a surprise coming.
Is it?
Yes, it is. It is. It
Surprise
is.
for me also then. It is a surprise for
We
me.
both
also.
at the surprise event. Yes, let's just
Surprise
show
is
them.
tomorrow.
Yes?
Let me remember the surprise. No, do not like. Oh, it's not refreshed, I guess.
Yeah, it's not refreshed.
It's not refreshed.
Let's just show them this one, yeah? Links, all the links for those
Everyone
who
is
joined
asking.
new.
Students, join the
Yeah.
Telegram channel. All the session updates, all the notes, everything. This PDF, every single PDF from all the sessions will be given on this Telegram
I
channel.
think this PDF we will club it and give students because just by giving parts it won't work. Okay, we will
Click
give
on here,
together.
this will join. Open it. Mistakenly clicked on it. Then we have victory mock.
It's there, no, they were not able to find.
What are you doing? Okay, chat is here. Sorry. I'm looking somewhere else. See here. That is the victory mock test is here. Then if you go down, the PYQs will be present in other different videos. Every single video you will find NCERT based question, you'll find a quiz, you'll also find different types of previous year questions, every single thing on every single video. So you do not have to go anywhere. Every single thing is there on this channel.
Okay, did you show them, no, the victory mock test? Did you click on that link?
No, I did not.
Students, let us know how the class was. How was bio? Do you want no fun class?
Free, oh.
Just enroll now. Yes, they have to enter their phone number.
Phone number, that's all.
Okay, phone number or the email. Okay.
Ah.
Students, let us know how the bio class was.
Do not forget to comment. These last
They won't
minute-
comment.
They won't comment. You bet. We'll have a bet.
Bring them back here.
Ma'am, we'll have a bet if they comment or not. You're saying they'll not comment.
Ah.
I am telling they will comment this time. So students, we will have a small,
No, artificial insemination and your intrauterine, what is that? IUI, AI, all that is same, students. Just bringing the sperm into the ovum. Okay, that's it. Diksha.
So students, ma'am's bet is you guys will not comment in today's video. My bet is you will comment in the video. Let's see who will win. If it's gonna be ma'am or it's gonna be me. Don't be like, sir, we don't want to comment because ma'am wants to win. Please make me win also, right? So with that being said, let's get. Okay. Can we get? Ma'am is there? Ma'am is coming. Disha ma'am.
Yeah, she'll join.
Okay, students.
What did they say? They enjoyed or they want very serious session?
I don't know, ma'am.
Bring them here, no, please. I want to see their comments.
You can see. They won't. Okay, fine. We'll bring it.
No, we'll just bring it there and then Diksha ma'am will join. So we'll have a proper thanks. Last time also we didn't say thanks. It just went like that.
Ah.
Yeah. I mean, we told, but it didn't come, I guess. Yes. Students, let us know how was the session. Oh, they're telling you will win, sir. Let's see.
Yes, obviously.
Okay. Students, tomorrow a surprise is coming. And I will not reveal the surprise. But then understand tomorrow a surprise is coming. And it is only for the serious NEET aspirants. It is not for the ones who are not serious or who do not want to crack NEET this year. It is only for the serious NEET aspirants, be it 2024 or 2025, but only for the serious people. Okay?
Yeah.
Yes?
Very serious. If
Yes.
you're time pass, just go to time pass. You will come back here after 1 year. To NEET 2025 is for you, not 2024.
Yes.
Okay then.
Students, we have taken both the chapters questions together. The number does not matter. Okay. It is not about the number. It is about solving the entire chapter. You can take NCERT and let us know, ma'am, this paragraph we didn't solve one question also. We'll be ready to accept it. Okay. We have gone through NCERT. We have taught the chapter.
Everything
and we
is
know
done.
it. Okay.
So we will see you in the next class. That is, we have a class on Sunday, ma'am.
Yeah, I have a class, sexual reproduction.
ma'am. Tell me.
Sexual reproduction in flowering plants. I stole it from Baswa sir, one botany chapter, which I'll be doing Sunday, 5 o'clock. That means after your mock test, maybe I'll give you half an hour break, and we will join at 5:30. Okay, ready?
It's because I took human reproduction from ma'am. Ma'am is taking my chapter. Okay.
Yes.
Cool
Yes.
then.
Thank you, Anupam. Thank you so much,
bye-bye.
NEET aspirants. Okay. I think a lot of them told. Thank you so much, students. Now, Diksha ma'am is going to join, so do not go
Yes.
anywhere else.
Lily AC has been deleted. Lily AC has deleted the old syllabus. New families I've done on the channel. You can go watch that channel on that. You can go watch that video which is there on the channel. Oof. My vocabulary with Gopika is gone.
Blame me for that.
Okay, bye students. Take care.
Bye.
Okay, am I audible now? Am I audible now? Am I audible? Are you able to listen? So, hi everyone, I am Diksha Kaushal, your chemistry master teacher. I'm so sorry for the audio. Tell me about that. How was your physics and biology session? How was it? Did you enjoy that? Did you enjoy that, everybody? Did you enjoy? Everybody, yes ma'am. Okay, perfect. So guys, today we are going to do coordination compounds, a very important chapter of inorganic chemistry and a very interesting chapter also, right? So we are going to do 100 questions from inorganic chemistry, coordination compounds line by line. Are you all ready for that? Everybody in the comment section, everybody in the chat section, are you all ready for coordination chemistry? Are you all ready? I want all of you, do not lose your energy. Do not lose your energy, because even I was teaching from 5 o'clock, even I was teaching 5 to 7:30 I had a class, and now I am full of energy. Then you should also be full of energy. I am also teaching for 4 hours, okay? Still I have that much energy. So where is your energy? You should also be like you should also have that kind of energy, okay? Okay everyone? Yes. Yes, everybody, are you ready? Shall we start? I don't see the energy here. I don't see the energy here. Yes, ma'am. Yes, ma'am. Everybody fire in the chat box. Everybody. It's a very important chapter that we are going to do today. Right? We did DNF block. Now we are doing coordination compounds. From inorganic chemistry, line to line is important, right? Yes. With full battery, yes, the battery should be full charge. So let us start with the first question, that is the transition metals. Okay, after DNF block, we are going to do coordination chemistry. I'll tell you some of the basics also in between of the coordination chemistry also, right? Perfect. Everybody fire in the chat box. Fire in the chat box. Okay. Hearts in the chat box. Everybody, I can see that. I can see it. Am I going blind? I can see the hearts. I can see the fire. Where is that? Am I going blind or what? Why I can't see that fire? I should see that. Okay. Yes. Perfect. Yes. Okay. So let us start. Firstly, we have the ligand transition. The transition metal in the coordination compounds share electrons with the number of anions and neutral molecules, which are termed as these molecules. What are these molecules called? Okay, they are saying transition metal compounds in the coordination compounds share electrons with number of anions or neutral molecules, which are termed as, what kind of molecules are they? Everybody, perfect, very nice. What kind of molecule are they? Everybody, they are ligand or coordinating molecules. What they share the electrons. Okay, ligands are electron donors. They donate the electrons. Metal accepts the electrons, right? Okay, perfect. Ligands donate, metals accept. That is the relation between ligands and metals, and that is how coordination compounds are formed. If they are in the equimolar ratio, then we'll have the formation of double salts. If not in the equimolar ratio, then we will have the formation of coordination compounds. Next, we have Werner proposed. There was a theory, that is Werner's theory. He tell about two things. What are these two things? Everybody. The concept of primary valency and dash valency for the metal ion. There were two valencies that he talked about. First was primary and the second was secondary valency. Okay, this was secondary valency. This was secondary valency. Primary valency, secondary valency. Now, secondary valency is what? Secondary valency is nothing but coordination number. Okay. Yes, primary and secondary valency. The dash number is fixed for metal and the reflects. Okay, dash number is fixed for a metal. What number is fixed for a metal? And reflects a number of groups bound directly to the metal ion. This is the metal. The number of groups that are directly bound to the metal ion. What are these metal? These things called? What is the name of these things? Everybody, yes. What is the name of this thing? This is called the dash number, that is coordination number. How many species? For example, you have a coordination compound. This is some metal M. This is ligand. This is 4. Here the coordination number is 4. How many metals are bound to that? How many ligands are bound to that metal directly? Okay, that are called coordination number. Werner introduced the idea that ligands groups bound the secondary linkage. He introduced something that the ligands or groups bound to by the secondary linkage to the metal have characteristics of dash arrangement. That the ligands that are bound to the metal, they have different kind of arrangements. What are these different kind of arrangements called? He also named it one thing, that is coordination polyhedron. Okay. Yes, bacha. Yes. Everybody in the chat box. Yes. What are these called? What are these called? Characteristics dash arrangement. These are called spatial. These are what called? These are called spatial arrangements. Okay. It forms a tetrahedral shape, square planar shape, octahedral shape. Different types of shapes are formed there. That is called coordination polyhedron. Okay. Next we have a dash like KC. What is this called? What is this called? This dissociates into simple ions completely in water. But then we have this kind of compound. In this kind of compound, it will dissociate what into? Like this does not. Why this does not dissociate? Because the ligands in the metal, the things that are present inside that bracket do not dissociate into ions. Okay, we cannot further dissociate this thing. Okay, so now what is this called? A dash like this is what is this? Everybody, this is a type of double salt. Okay, this is the type of double salt like this dissociate into simple ions. Next we have, whereas this, what is this? This is a coordination complex. This is a coordination complex. This is a double salt. This is a double salt. This is a coordination complex. Okay, everybody? Yes, perfect. Okay, now next we have Werner's theory. Basically, this theory is all about primary and secondary valencies. Okay, so now what are primary and secondary valencies? The Werner's linkage, we have some postulates to this theory. So from that theory, Werner's theory proposed that the number of dash linkages is equal to coordination number. What kind of linkages is he talking about? The number of dash linkages is equal to coordination number. What is the coordination number? Everybody in the chat box. What is coordination number? It is secondary valency. They are talking about the secondary valency. Okay, this is secondary valency, right? So he is talking about the number of dash linkages, the linkages that are directly to this. Okay, the number of secondary linkages, right? That is called coordination. And what is primary? That is the oxidation number. The oxidation number is called primary valency. Okay. Next we have the primary valency are dashed and are satisfied by negative ions. The primary valency, I just told you that. Okay, I just told you that. Everybody in the chat box, I want all of you to answer this. I want all of you to answer this. Bacha, we are covering coordination compounds today, a very important chapter, very scoring chapter. Yes. So this is the primary valency are dash and are satisfied by negative ions. What does this mean? The primary valency are oxidation number. Okay, the primary, we can also say these are oxidation number. So see one thing, the primary valency are ionizable and the secondary valency are non-ionizable. Secondary is non-ionizable. Okay, it does not ionize. What does this mean? For oxidation number, we all know that it can be plus 3, 4, 3. So according to the ions that are lost, we decide the oxidation number. But the coordination number is not according to the number of electron that is lose, the number of electron that it gains, right? So that is why this is non-ionizable. Okay? Yes. The secondary valency are that they are satisfied by neutral molecules or negative ions. They are saying the secondary valency, they are talking about the coordination number, right? They are non-ionizable. They are satisfied by neutral or negative ions. But these are not satisfied by, these are satisfied by only negative ions, not neutral ions. Okay, these are only satisfied, oxidation number is only satisfied by negative ions. This is satisfied by, you can have neutral ligands, you can have negative ligands both, right? So this is, the secondary valency is non-ionizable. Okay, the answer will be non-ionizable. Okay, next we have a coordination entity constitutes a central. We have, oh, this is very simple. Or ion bonded to fixed number of ions or molecules. What does this coordination entity mean? It consists of a central, what we have ligands, and then we have central metal atom. Central metal atom, and then we have ligands. We have two things, right? In the coordination entity, this is the coordination entity, right? We have this metal and we have this ligand that is bonded to the metal, right? It donates and it accepts. right? Okay, perfect. Atoms or ions to which fixed number of groups are bound. What he is saying? The atoms or ions to which fixed number of groups are bound in a definite geometrical arrangement around it is called. What is this arrangement? What is this arrangement called, everybody? What is this arrangement called? I want you guys to answer this. Very good, very good. Deepak, Desat, Samria, then Azra. Okay, my eyes are, I think I need to wear spectacles now. Uma, very good. Harshida, everybody. What is this called? This is called central atom. The atoms or ion to which fixed number of ligands are bound. What is this called? That is central metal ion. It's a metal. And ligands are bound to this. Right? That is called total coordination complex. Very nice. Next we have the ions or molecules such as Cl, H2O and H3 that are bound to central metal atom in the coordination entity. Very simple. They are called ligands. They are called what? They are called ligands. Very simple. Next we have, very nice, ethylene diamine tetraacetate. Wow, what a question this is. What a question this is. Now I want all of you to understand one thing about this. You have, this is called EDTA, very, very important thing. EDTA you have, ethylene diamine tetraacetate, right? So he's saying 4 negative here is an important hexadentate ligand. It can be bind through 2 dash atoms and 4 oxygen atom. So what is the structure of this? Firstly, I want all of you to answer this. Firstly, I want all of you to answer this, then I will tell the structure of this compound. Firstly, answer this. Everybody answer this question. Then I will tell you something about this compound. Something very important about this compound. Okay? Yes. Perfect. 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 No. It bonds through 2 nitrogen atoms. These are 2 nitrogen atoms and 4 oxygen atoms. And how it is done? Let us see how it is done. 2 nitrogen atoms and we are talking about 4 oxygen atoms. So we have this nitrogen here, the nitrogen here. Then we have this thing. Now it is attached to CH. This is CO negative. Yeah. Okay. Wait. Yes. CH3CO negative. CH3CO negative. Or I will just directly write it something like this. Tetraacetate, right? This is tetraacetate. This is ethylene diamine. This structure is ethylene diamine, right? This is ethylene diamine, right? This is ethylene diamine. Now 4 acetate groups are attached to it, so I'll apply it here. So 4 acetate groups, that is CH3COH. This is CH3COH. This is CH3COOH. Now everybody in the chat box, what you will see here. This is simple EDTA with no charge. It has no charge. When EDTA does not have any charge, it has just 2 donating sides, that are these 2 nitrogen. Here it will be bidentate. This EDTA will be bidentate. I am writing it here. EDTA with no charge is bidentate, bacha. EDTA with no charge is bidentate. Right now, no oxygen atom is free for the electron donation, right? Here, if I say EDTA 1 negative, that means 1 H positive will lose here, right? There will be negative here. So it will be EDTA minus 1, that we have 1, 2 and 3 sides. This is tridentate. Okay. If we lose H positive here also, wait. If we lose H positive here also, there will be negative here. This is EDTA. Now tell me, this is EDTA minus 2 having 1, 2, 3, 4 sides. Okay. This is tetradentate. Okay. This is tetradentate. Now we have, if I lose H positive from here also, then I'll have 3 negative here. So it will be EDTA. This will be EDTA minus 3. It will have 1, 2, 3, 4, 5 dentate. Okay. This is pentadentate. Then we have EDTA, very, very important, that is being asked. That usually students just cram this thing that EDTA means it is hexadentate. No, EDTA with what charge it has. If it is neutral, that it will have just 2 donating sides. Okay. So now if we have 4 negative, that means these 4 oxygen and these 2 nitrogen, it will be hexadentate. Is this clear to everyone? Right? Clear? Perfect. Okay. Should we move ahead? Everybody, yes, remove H from COH. Perfect. Okay, so now next we have ethylene diamine. This is an important hexadentate. It binds to this. We have done this already, repeated question. Next, the coordination number Cn of metal ion in the complex is defined as. the coordination number of Cn, okay, they're saying the coordination number of Cn of the metal ion, the complex is defined in number of dash donor atoms to which the metal ion directly bonded. Which is the donor atom here? In the Cn, which is the donor atom? The donor atom is this nitrogen. This nitrogen is the donor atom. This is a species like this, okay? It has one lone pair, so this nitrogen is the donor atom here. So answer will be the number of dash ligand donor atoms to which the metal is directly bonded. The coordination number to metal in this complex is defined to the number of nitrogen atom that are donor atom to how many Cn are they linked to each other. That will define the number of ligands here, okay? So now next we have very important question. So now you have to know one thing, okay? You have to know one thing, that this is a strong ligand. And what is this? Everybody in the chat box, Cl is a weak ligand or a strong ligand? Everybody in the chat box, I want all of you to answer this. Cl is a weak ligand or a strong ligand? CLF, these are weak ligands, right? Okay, understood? For example, you have, this is a weak ligand, right? This is a weak ligand. For example, strong ligands are like, you have NH3, you have C2O4, 2 minus, or you have CN. These are all strong ligands, right? All these are strong ligands. You have water, these are strong ligands, right? And this is weak ligand. So strong ligands, what will happen in strong ligands? There will be pairing. And in weak ligands, there will be no pairing, right? Okay, according to the strong and the weak ligand. The coordination number of PT and this are, now you have to tell the coordination. It's a very simple thing, right? 4, and this is also 4. The number of ligands that are attached to it, there's a 4 and 4, that answer will be 4 and 4, right? The spatial arrangement of the ligands atom to which they are directly attached to the centimeter ion defines dash about the central atom. Okay, they're saying the spatial arrangement of the ligand. What does the spatial arrangement? They're talking about the shapes. VBT theory. About the shapes. What does it tell about the centimetal atom? Is it a strong ligand? Is it a weak ligand? How many ligands are connected to it? What does it tell us about it? The shapes, what did it do? Coordination polyhedron, as I already told you. Okay, this is coordination. What is this coordination polyhedron? Like we have the octahedral will be like this. Okay, this is the octahedral. Like if you have this if you have this trigonal planar, trigonal pentagonal, okay, these trigonal bipyramidal or pentagonal or square planar, or you can also have square planar also, right? These kind of species, okay, these kind of arrangements can be present there. That is called coordination polyhedron. Okay, understood? Now next we have in this the shape of coordination polyhedrons. The shape of coordination polyhedron. How do you define the shape of coordination polyhedron? How do we define it, everybody? This is a neutral ligand, right? So firstly what we will do, we'll see the oxidation number of cobalt here. This is X, this is +0, this is +3, right? So answer will be X is equals to +3. This will be the coordination, okay? This will be the coordination number. So everybody, so it will be cobalt 3 positive. Saktiv Karman Fico Niku Fico, that is 27. Cobalt is 27, that means argon 18, 4s, then we have 3d, okay? 4s, then we will have 3d. It will be 2 electrons here, 7 electrons here. It will lose 3 electrons. So this will be cobalt 3 positive. 2 electrons will be here, will leave from here, and there will be 1 electron from here. There will be 6 electron here, okay? We'll have 3d6. 3d6. Now let us see, this is the strong field ligand, right? So let us see, this is a strong 1, 2, 3, 4, this is 5. Strong field ligand means there will be pairing, right? There will be pairing. So let us see, strong field ligand, there will be pairing. So we have 1, 2, 3, 4, 5, 6. And after pairing, what will happen here? 6, 1, 2, 3, 4, 5, 6. This is D2sp3. Because of 6, okay, I'll tell you one thing. I'll tell you just one thing. Okay. So we have this chart, that is sp3. Then we have dsp2. Then we have sp3d. Then we have d2sp3. Then we have sp3d2. Here the shapes are octahedral. Okay, here the shapes of octahedral. This is trigonal bipyramidal. This is trigonal bipyramidal. Bipyramidal. And this is tetrahedral. This is tetrahedral. And this is square planar. This is square planar. Usually this is asked or this is asked. It will have 6 ligands, it will have 5 ligands, it will have 4 ligands. Okay, everybody, this is how you will tell the geometry of any orbital. Okay, this is how, this is what is this? This is inner orbital, this is outer orbital. So now let us see the geometry here. This geometry will be D2sp3. Okay, there will be S here, there will be P here. Okay, this is D2. The ligand will attach here, 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 here. D2sp3. That means the coordination polyhedron will be octahedral firstly, and the geometry that hybridization will be D2sp3. Okay, hybridization will be D2sp3. D2sp3. We can also write it as inner complex. This will be a inner complex. Okay, this will be a inner complex. Understood this, guys? Okay, right? Perfect, perfect. Okay, next we have the dash of the centimetal atom in the complex is defined as the charge it would carry if all the dash were removed along with the electrons pair that are shared with the central metal atom. Okay, the dash of the central metal, the oxidation number of the central metal in the complex is defined as the charge that would carry all the ligands. Okay, that would carry all the ligands were removed along with the electrons pairs are shared with the center. How do we calculate the oxidation number? Here, how did we calculate the oxidation number? It is a method, right? We assume that if this all is removed, okay, then we assume that and then we calculate the number of, what is the oxidation number of that species, right? Okay, yes. After that, we have the next question, that is for the complex. The oxidation number of copper is very simple. This is X is equals to +1, right? It is a neutral ligand, so the value is 0 here. So this is X plus 0 is equals to +1. This is copper positive. And also I want to tell you one thing about copper positive that can be asked in your examination, that copper positive has pseudo noble gas configuration. Pseudo noble gas, very, very important thing. It has pseudo noble gas configuration. How do we define it? What is pseudo gas noble configuration? So see, you have copper positive. What is the electronic configuration? The electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6. This is the argon, right? After that we are talking about copper positive, no? So the electronic configuration is 4s0, 3d10. This is about the electronic configuration. One electron will be lost from here. This is exceptional electronic configuration. So instead of this thing, the one electron jumped here and it became 4s1, 3d10 because of fully filled orbitals, right? Okay, so now we have this configuration and you will see here pseudo noble gas configuration means the outer shell should have same number of electron as there are in any noble gas. The outer shell here is third shell, okay? Here the outermost shell is third shell, that means third shell, okay? Here we have no electrons, so the outer shell here is third shell. So the outer shell has how many electrons? This is 2 plus 6 plus 10, that is 18 electrons. That means according to, this is the number of electrons in argons. So that means it follows pseudo noble gas configuration. Now tell me one thing about it. Does Na positive, does it have pseudo noble gas configuration? Does sodium positive has pseudo noble gas configuration? Let us see, okay? So now here we have 1s2, 2s2, 2p6, 3s2, and then we have, okay, this is 10, this is 1, okay, this is 1, right? Yes, okay, perfect. So now this is about sodium. If we talk about sodium positive, one electron will be lost from here, okay? What is the outermost shell here? What is the outermost shell, bacha? What is the outermost shell? The outermost shell is 2. The outermost shell is 2, okay? because here we see no electrons, so outermost shell will be 2 in Na positive. Okay, so the calculate the number of electron here, that is 2 plus 6, that is 8, which is not equals to any noble gas electrons. This is not equals to any noble gas electrons, so it does not follow no pseudo noble gas configuration. No pseudo noble gas configuration. Okay, no pseudo noble gas configuration is present here. Okay guys, everybody, now let us see the next question here. Let us see the next question here. For the complex the oxidation number of copper, we have already done this. Okay, next is the complex in which a metal is bound to only one kind of donor atom. Only one kind of donor atom, that is known as, similarly, for example, this, where the ligand is of just one type. There is no different variety of ligands in one single coordination entity. That is called as homoleptic. Okay, if there is more than one type of ligands, then that will be heteroleptic. Okay, that will be heteroleptic. Now next we have the complex. This includes the central metal this and the counter ion this. Okay, perfect. Everybody, I want all of you to answer, bacha. I want all of you to answer. Okay, the complex this. Okay, this is the complex. Okay, if we see that this will be FeCN. This is 6. This is positive. This is the kind of complex that they are talking about. Okay, this is positive. This should be negative. Okay, includes the central ion Fe3 positive. The counter ion is what is the counter ion? Okay, includes the center metal ion Fe3 positive. Okay, so what is the counter ion present here? What is the counter ion? Where you can see the counter ion? What is the counter ion, bacha? What is the counter ion present here? This K positive is the counter ion. Okay, this is center metal ion. This is the counter ion. Very simple. Very simple. The ligands which has two different donor atoms and either of two ligates is in the complex is called. It has two different. We have two different. The either of two ligates in the complex, this is called heteroleptic. And the two, okay, so he is talking about, for example, we have NO2, right? For example, we have NO2. So it can donate from two sides. If something can donate from two sides, that is called bidentate. That is called ambidentate. That is called ambidentate. The ligand which has two different donor atoms. A single molecule has two different donor atoms. No, CN was not the right example for that. Okay, that is having a ligand has two different sides. That is called ambidentate. Ambi means two. Ambi means amphoteric is what? Amphoteric is which behave as both acid as base. Okay. Similarly, ambidentate is something that is having more than two or more than one donating sites. Okay, perfect. Then SCN can coordinate through dash atom or the nitrogen atom. This is ambidentate. Okay, this is ambidentate. It can coordinate through dash atom or the nitrogen atom. What is the other atom that it can donate through? What is the other atom, guys? I want every one of you to answer. What is the other atom? That is sulfur. Okay, it can donate to sulfur or nitrogen, right? When a ligand has two or more donor atoms, it is called, what it is called? We just read it. Okay, this is called polydentate ligand. When it has two or more donor atoms, okay, two or more donor atoms, that is called polydentate ligand. Next we have complex which contains more than one kind of donor atom. More than one kind of, that is heteroleptic. Okay, more than one kind of ligands. The complex entity has more than one. It has one Cl, one NH3, that is called heteroleptic. The in complexes counter ion is written outside the, where they are written, where the counter ions are written, they are outside that bracket. What is that called? The bracket, that is called the bracket, the parenthesis, or they are also called this bracket. Okay, this bracket, the outside metal is called the counter ion. Okay, the inside one is called the center metal ion. Next we have the oxidation state of metal in cation, anion or neutral entity is indicated by dash in the parenthesis. Okay, the oxidation number of the metal in the cation and anion on this entity is indicated by, in the IUPAC naming, it is indicated by what? It is indicated by some Roman letters. Okay, it is indicated by some Roman letters. You know how to do the IUPAC naming, right? There are so many questions based on IUPAC naming, right? Very important questions based on IUPAC naming. So the numbers, that is the oxidation number. For example, you have ferric ion, right? So it will be, for example, the ferric is as an anion, okay? The complex entity, okay, the negative entity, the complex entity, the coordination entity is the anion here, right? So in this case, you will write ferrate, okay? And by ferrate, you will write, if this is Fe3 positive, you will write ferrate 3, okay? This will be ferrate 3, right? Okay. So now next we have mononuclear coordination entity contain a single centimeter. Mononuclear coordination entity contains single centimeter. The dash is listed first in the formula. Which is listed first in the formula? They're talking about the formula, not the IUPAC naming here. Here we are talking about the formula, okay, bacha? Here we are talking about the formulas. In the formulas, the things are very opposite. In the formulas, how you define the formula? The centimeter atom is written first. This is cationic and this is anionic entity, right? If the mononuclear coordination entity contains single this, the dash is listed first in the formula. Which is listed? This is cationic, this is anionic, okay? So, central metal ion is first in the formula. This is your bracket, okay? This is metal, this is ligand, and this is some, how many coordination number it has. So, always first, okay? This can be cationic, this can be anionic, okay? This can be anionic, this can be cationic. All these are possible. The bracket can be cationic, the bracket can be anionic, right? Okay, perfect. The ligands in the coordination compounds are listed in the order. How they are listed? They are listed in which kind of order? Like you list amine and all that. In the coordination compound are listed in what kind of order? They are listed in the alphabetical order. Okay, amine first, after that. In the alphabetical, the names of the alphabet they have. Okay, they are listed accordingly. Next we have polydentate ligands are also listed in alphabetical order. In case of abbreviated ligand, the first letter of dash is used to determine the position of ligand in the abbreviation order. Very important. In case of abbreviated ligand, the first letter of dash is used to determine the position of the ligand in the abbreviated letter. Everybody, what is the answer? The first letter of abbreviation. Okay, if there is abbreviated ligands, okay, we have EN, that kind of thing they are talking about. Okay, next we have the formula for the entire coordination entity, whether charged or not charged, is enclosed in dash brackets. I told you, whether charged answer, that is in the square bracket. Okay, this kind of bracket, right? Okay, perfect. The ligands are polyatomic, their formula are enclosed in. The ligands which are polyatomic, their formula are enclosed in. Okay, how they are enclosed, the formulas, how we write them, For example, this is En, right? We write it like this. Okay, the polyatomic ions are written like this, right? Okay, parenthesis. Okay, they are talking about this thing. This is the bracket, this is the parenthesis. Okay, understood? Understood, guys? This is the ligand, name N, right? This is ligand number 1. For example, this is the proper bracket. This is ligand number 1. Or I'll write it as ligand 1 with N number, ligand 2 with M number. This is the metal. Like this we are talking about. Okay, when the formula of the charge coordination entity is to be written without that of counter ion, then what we do? The charge is indicated outside the square bracket as a what? That is indicated here, right? That is indicated here or here, right? That is indicated in the right superscript. Okay, this is indicated here, right? Okay, the charge is indicated here. Now next we have the charge of the cation is balanced by charge of dash in the formula of complex compound. The charge of the cation is balanced by the anionic part of that. Okay, the anionic part of that. In the naming, now we are talking about the IUPAC naming of coordination compounds. The dash is first in both positively and negatively charged coordination entities. Which is first here? Which is first here? Always remember, when we are writing the formula, the metal is first. In writing the IUPAC naming, the ligand is first. Okay, so here the ligand is first. Oh, wait, the dash is first. Okay, yeah, that thing was also right. Okay, this thing is also right. So cation is written firstly everywhere. In chemistry, cation is written firstly, then an ion is written. Okay, even if this is bracket and this is the metal, if this is the bracket can be cationic, this can be anionic. That is written firstly. Okay, the cationic part, whether it's in the bracket or it's not in the coordination entity, that is written first. And in the coordination entity, when we are talking about the formula, the metal ion is written firstly, but in the IUPAC naming, the ligands are written firstly. Okay, perfect. The complex, this is named as, what is the name of this complex? Everybody, I want all of you to answer this. This is a coordination compound. I want all of you to answer this question. Okay, everybody, what is the name of this complex? Perfect. This is a cationic, this is an ionic, right? This is cationic, this is an ionic. The coordination entity is cationic here. So firstly, while writing the IUPAC naming, we will firstly write the ligands here. Okay, according to the alphabetical order here. Now, we have, this is aqua, this is amine. This is aqua, this is amine. This is, so, if you do not have any di, tri, something in your ligand, then you will simply write di, tri, okay? But if you have a ligand like EDTA, like EN, like ethylene diamine, in that case, you will write bis, tris, tetra, kiss, all these things. Okay, so here you have, this is amine, this will be alphabetical order, tetramine, di, aqua, and then this is cationic, so we'll write it as chromium, and this will be, oxidation number will be in the brackets, and this will be chloride. Okay, perfect. So let me see how many students. Chromium, chloride, perfect. Tetramine, diaqua, chromium 3. Yes, very nice. Tetramine, diaqua, chromium, this chloride. Okay, perfect. Understood? Tetraamine, according to the alphabetical, or always in case of amine there is double M. In case of amine there is double M here, no single M. Okay, tetraamine, diaqua, trichloro. And why amine is firstly and then aqua? Because A is same. Okay, in this A is same, this is aqua. So first letter is same, but the second letter is different, and here M wins over Q. So here we will write amine firstly, then aqua. So aqua, then amine, then we have chromium. The oxidation number here we will calculate X plus 0 equals, so this will be plus 3, right? This will be plus 3. This is minus 3 because we have 3 chloride ions. This will be plus 3. So X is equals to plus 3. We will write it as this bracket Roman 3. Right? Okay, guys? Yes, perfect. Okay. So now in the square planar complex of the formula, this, the X and L are attached to each other in the cis isomer. They're talking about the cis isomer. Okay. In the cis isomer, what will happen? In the cis isomer, they will be, what is the cis isomer? Cis isomer is that isomer where they are present in the same, like on the same side. And in the trans isomer, they are present on the opposite side. Right? In the cis isomer, they will be present on the same side, adjacent side, like this. Okay, for example, this is metal. We have X and this will be X, this will be L, this will be L. In the trans, we'll have this X and this will be L. This will be X and this will be L and this will be L. So this is cis and this is trans. This is trans. Okay, guys? Yes? Okay, this is from isomerism. Isomerism of coordination compound is a very important topic. 2-3 topics for coordination compounds, the theories and isomerism. Very important. IUPAC naming as well. They can ask question from any of this topic. Right? So isomer that have the same chemical formula and chemical bonds. They have same chemical but different dash arrangement. What kind of arrangement? Okay, they have different kind of spatial arrangement. They are called stereoisomers. Optical isomers are mirror images that cannot be dashed on one another. That cannot be. Optical are mirror images that cannot be superimposed on each other. Okay, that cannot be superimposed on each other. Right? Linkage isomerism arises in the coordination compound. Linkage isomerism, what is this? There are different kind of isomerism. There is solvent isomerism, linkage isomerism, a different type of isomerisms. Coordination isomerism, right? So what is linkage isomerism? That means the linkage is different here. The ligands may be inner or outside, okay? So there is containing linkage isomerism in the coordination compounds containing ambidient ligand. There will be linkage will be different. For example, we have NO2, right? And we have ONO. So it can be linked with N or it can be linked with O. So that is the difference. For example, we have SCN, right? It can be linked with the nitrogen or it can be linked with this nitrogen, or it can be linked with this sulfur. So there are two chances to it. The linkage can be different. Okay, the linkage can be different here. Perfect. Yes. For the complex ion this, now they are talking about the complex ion this, the transform has two chloride ions. The transform has two chloride ions. Perfect. On dash sides of the center. Very simple, on the opposite side of the center metal ion. Okay, the neutral complex molecule is named similar to that of, the neutral complex molecule is named similar to that of the complex, okay. What is this called? Pseudo configuration. Achha ji, perfect. Yes, opposite to each other. On the neutral complex molecule is named similar to that of complex cation. Okay, so they're talking about the neutral complex and the, okay, so what they're talking about, if you have something, if you have a bracket that is anionic, okay, in that case central metal atom will be written as 8. Okay, the last word, the last letters of center metal atom ion will be the suffix of center metal ion will be 8 if the coordination entity is negative. But if the coordination entity is 0 or it is neutral, it is written in the same way. Okay, it is written in the same way like chromium. But if chromium is in the negative entity, if here was chromium, then we will write it as chromate, not chromium. Okay, if there is chromium here, we will write it as chromate, not chromium, ferrate. Okay, these kind of things, right? Okay, now next we have the name of the complex ion. This is, what is this complex ion named? There are two different complexes. What it can do, what kind of isomerism it can show. Everybody, the name. Firstly, tell me the name of this ion. This is the positive, this is the negative, right? This here, how to find the coordination, how to find the oxidation state? By hit and trial method. Okay, by hit and trial method. If this is 0, here if I take the oxidation, this is +1, this is -1. Okay, if I take this +1, this -1, there will always be hit and trial method in these kind of coordination complexes. This is +1, this is -1. So in +1, what you will do, for example, we have taken it as +1, this is x plus 0 is equals to +1. So Ag will have +1, right? And here this is x minus 2 is equals to -1. Again Ag will have +1. And Ag is stable in +1 oxidation. That means it will carry +1 oxidation state. Ag has, in DNF block, we will study that Ag has +1 oxidation state as a stable oxidation state. So Ag positive exists. So we'll say yes, the coordination number here is a +1, this is -1. The coordination number this also has coordination number oxidation number +1. This also has +1 oxidation number. This is amine, this is science, this is cyano, right? So just write it down. Everybody, I want all of you to answer the names of this. Okay, everybody, I want all of you to answer the name. Coordination, very nice. This is coordination isomerism. The name of isomerism is coordination isomerism. What is the name of this complex? What is the name of this complex, everybody? What is the name of this complex? Now see this very important thing. Okay, firstly we will write the cationic part here. This will be amine, this will be diamine. And now here it is in the positive state. Everybody see, this Ag positive is in cationic bracket, is in cationic sphere or cationic bracket. And here Ag positive is in anionic sphere. It is in anionic sphere. So when in anionic sphere, when any metal is in the anionic sphere, we apply 8 there. So that is why we have written here argentate. Okay, we have written here argentate, right? That is the Latin name, okay, of silver. But here we have written silver. Here we have written silver because it is in the cationic state. But here we will write with the Latin name, that is 8. Latin name plus 8. So that is argentate. The name here will be argentate. That is what makes this very important. So this is diamine silver 1, dicyanide. This is dicyanide argentate. Okay, 1 again. Understood, everyone? Understood? A very important question. This is a very important question. Okay, very important question. Everybody understood this? No issues in that? Okay, yes, argentate, and this is silver. Perfect. So now next we have dash is not possible in tetrahedral complexes. What is not possible in tetrahedral complexes? Having two different types of unidentate ligand. It has that is not possible in two different types of unidentate ligands. It is a unidentate, that means it just have one donating sites, two types, coordination with the center metal ion, because the relative position of ligands attached to center metal ion are the same with respect to each other. Tetrahedral complexes they are talking about, two different types of unidentate ligands are there. So because the relative position of ligands attached to the center metal ion are same with respect to each other. Yes, what is not possible? Everybody, yes, everybody, perfect, very nice. Cis and trans here is not possible. That is, geometrical isomerism is not possible in this case. There are certain conditions for geometrical isomerism, right? Okay, perfect. The molecules or the ions that cannot be superimposed on their mirror images, that cannot be superimposed, what are these called? What are these called? What are these kind of isomerism? We have, this is a very important part of optical isomerism in organic chemistry as well. What is this called? These are called chiral. Okay, these are called chiral. The molecules ion that cannot be superimposed, or they are called they are called enantiomers, right? Cannot be superimposed on the mirror images. Chiral or enantiomers, we can say. Very nice, enantiomers, very nice. Okay, two forms of chiral molecules are dextro and levo. Oh. Okay. Sometimes in just energy we just say the answer out. Okay, two types of forms of chiral molecules are dextro and levo, right, depending upon the orientation in plane polarized, right? Okay, so now what is dextro? Now your question is how do we define dextro and how do we define levo? What is dextro and what is levo? What is dextro? That is symbolizes by small d and a positive, and levo is minus. Okay, levo is minus and L. So how do we define it? How do we define it, everybody in the chat box? How do we define it? DR. You want to be a doctor? You want to be a doctor? So dextro means right. It rotates the plane polarized right towards right. Okay, it towards left. Okay, this is towards left. Perfect, perfect, perfect. If we have 50 to 50 ratio of these two, that is called reciproc mixture. Okay, perfect. Yes. Next we have dash arises from interchange of ligands between cationic and anionic entities of different metal ion present in the complex. So there is change. They're talking about the isomerism. What kind of isomerism is here? Dash arises from the interchange of ligands between cationic and anionic. So this interchange of ligands, what does that isomerism is called? Perfect, guys. What does that isomerism called? There is interchange of ligand. That isomerism is called coordination isomerism. Okay. What does this mean? Like we also did that silver one. That silver one was coordination isomerism. Right? There's just change in the cationic and anionic thing. That is called coordination isomerism. Dash arises when the counter ion in the complex salt, counter ion itself is potential ligand and can displace a ligand, can become the counter ion. When, for example, this is the counter ion, let it be X, okay? Like this is M, this is L, this is N. So now they are saying this ligand and this counter ion are the same, okay? This can become a ligand or this can become a ligand as well. Okay, this ligand can become a potential ion as well. So in that case, what will happen? In that case, what happens? Okay, what kind of coordination is there? Ionization coordination is present there. Okay, in that case, ionization coordination is present in that complex. Okay. Solvate isomerism is known as hydrate isomerism in case with water is involved as. What is this? What is solvate isomerism? Where the hydrate molecules can differ. For example, in the bracket you have 6 hydrate molecules, but otherwise you will have, for example, this is a metal, this is Cl2 here, right? And you can have something like this, okay? H2O, this is 5, this is Cl, this is H2O and Cl, something like this, okay? There is difference in the ligands that are involved, the water that is involved as a ligand. So this is called solvate. This is called solvate isomerism, okay? Solvent isomerism, also called hydrated isomerism. So solvent isomerism known as this is this. We have already, this is called solvent isomerism. Werner was the first to describe the bonding features in coordination compounds. They are saying Werner was the first. He was the first person to describe the bonding feature in coordination chemistry. Otherwise, it was very complicated, complex. That what he actually told about. He initiated that. Okay, right? So, but his theory could not answer why coordination compounds have characteristics of dash and dash properties. What kind of properties that Werner was not able to explain by defining oxidation number and coordination number. By primary and secondary valency, he could not define. I want all of you to answer this. He could not define the, yes, one person has answered this. Others, bacha, magnetic and optical properties. He could not define the paramagnetic, the diamagnetic character. What is the reason? Why some are paired? Why some are unpaired? What is the reason behind that? Okay. So the dash hybridization results in tetrahedral geometrical arrangement and this. Very easy. Everybody, I want all of you to answer this. The dash coordination. What kind? The dash kind of isomerism. I made a chart for you there. Right? We made a chart. We made a chart of the hybridization and the kind of geometry. So they are talking about tetrahedral geometrical arrangements, right? What they are talking about? sp3. Very nice. They are talking about sp3 hybridization. Perfect. The dsp2 type of hybridization results in dash geometrical isomerism. I want all of you to answer this. dsp2. It has four, it needs four ligands only. Tetrahedral also needs 4 ligands only. It also needs 4 ligands. But the geometry here is different. Okay, the geometry here is different. The geometry here is very nice. The geometry here is square planar geometry. Okay, square planar geometry. Okay, perfect. The dash isomer of this shows optical activity. What kind of isomer of this shows optical activity? What kind of, it is bidentate, no? This is just one bidentate, so this and this, okay, shows optical activity. Which isomer will show optical activity? Everybody in the comment section. The dash isomer will show optical activity. The cis, okay. So here, what is the cis isomer? This is, how do we write it? We'll write it something like this, okay. This Cl, or we can write it as this, okay. What is this En? What is this En? What is the name of this En? What is En, everybody? What is En? Ethylene diamine. This is diamine and this is ethylene, okay. This is En, right? Okay. Ethylene. What is this? Everybody in the chat box, I want all of you to answer. What is En? What is diene? Okay. What is diene? What is the difference between diene and what is bisene? What is bisene? I want all of you to answer this. What is diene and what is bisene? What is the difference between this? What is diene and what is bisene? Anybody can answer this? This is bisene. This is diene. Bis means 2. Di means 2. What is the difference between these two things? Everybody. Diene. E means ethylene. Ethylene diamine. This means diethylene diamine. Diethylene. So this is one N atom. This is linked to diethylene, right? This is 2 ethylenes. It means diethylene. Okay. This means 2 types of ethylene. It means 2 ethylenes are there. It means 2 En molecules are there bonded to that M, right? So here we have this M. This is bonded to diethylene. Diethylene means we have, this is nitrogen. This is nitrogen and this is nitrogen. Yes, everybody just give me, yeah. I'll draw it like this, okay? Now, it is coordinately bonded like this, okay? So now this means this molecule whole together is called diene, right? This is just one molecule. This whole molecule is just one molecule. It has two ethylenes, right? That is called diene. This is diethylene triamine. Okay, this is diethylene triamine. This is represented as diene. Understood? So this may be, this is one H2, this is H2, and this is just one H here. Okay, guys. Now what is this? What is this? What is this bisene? This means two molecules of ethylene diamine. This is diethylene triamine, and this is two molecules of ene. Two molecules of ethylene diamine. Okay, so here we will write this as M, and two molecules of this means this is N, this is N, this is N, this is N. So there will be coordination bond. This is a coordinate bond between this, right? So two molecules of this means it will be like this. Okay, what is this? This is CH2, CH2. This is CH2, 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 CH2. So this is called, this is what? It has three sites. It has three donor sites, and it has four donor sites. It has four donor sites. Understood, everybody? Understood, everybody? Yes. Okay, perfect. The EN are two donor sites. EN has two donor sites, so this means bi-EN means, bis-EN means two molecules of EN has four donor sites. This is itself a different molecule. This is diene. Okay, everybody? Yes? Perfect? Okay, perfect. A complex ion like this, where NO2 can bind through nitrogen and oxygen, exhibit dash isomerism. The ambidient ligands, what kind of isomerism they exhibit? What kind of isomerism is seen in ambidient, which have two donating sites? The kind of isomerism is linkage isomerism. Okay. Now next we have this and this are example of dash isomers. Okay. So what is the difference here? What is the difference? There is exchange of the ion. Okay. There is exchange of the ion. What you will see here? Here we have Br, but here the Br is the counter ion. Okay. This is the counter ion. And here the Br is ligand. This is the ligand. Okay. Here the SO4 is ligand, and here SO4 is counter ion. We just did that example. Okay. So if one thing can behave as a ligand and as a counter ion in two different complexes, that is called as which isomerism? That is called ionization isomerism. Okay. Very nice. This is called ionization. This is not linkage. Okay. Linkage is ambidient. Yes. Perfect. This is ionization isomerism. Very nice. The hybrid orbitals form in the complex, these are called dash hybridized. The hybrid orbitals, what is this called? This is CO3 positive. Okay, CO3 positive. We already did this. We already did the hybridization and the hybridized geometry also. What is the geometry here? What was the hybridization here? Okay, everybody, I want all of you to answer it in the chat box. Okay, this was 27. So it will be argon 18, this is 4s2, this is 3d, this is 20, this is 7. So this will lose 2 electrons from here. So this will be 2 electron, and this will be 3d6. Okay, this will be 3d6, and because this is a very strong ligand, so it will pair up. So it will form 1, 2, 3, 4, 5. So it will have the pairing. This is 1, 2, 3, 4, 5, 6. So now it will have what kind of thing? This will be S, this will be P. So what is this called? Very good, everyone, very nice. This is inner or outer? Everybody, this is the formation of ligands here. Okay, so this is D2sp3. Okay, the hybridization here is D2sp3 hybridization, and this is octahedral inner geometry, right? Okay, D2sp3 octahedral, and we can also write it as inner. Right? Okay, perfect. On complex such as these kind of questions, oh my god, they are directly asked in your NEET examination. They are directly asked in your NEET examination. Very, very important questions are there. Okay. So now we have a complex, that is this complex, which is paramagnetic. Oh my god, wow. How do we define the paramagnetism? This is mu is equals to under root Nn plus 2. This is Bohr magneton. Okay. So now we have mu is equals to Nn plus 2. What is this N? This N is unpaired electrons. How do we see the unpaired electrons? By drawing it on, okay? By seeing the number of orbitals it has, how the electrons are filled in that. And for that we must know this is a weak ligand, okay? This is a weak ligand. This is a weak ligand, everybody. How you will see this? Okay, this is X. What is the oxidation number here? Everybody, I want all of you to answer this. This is X minus, this is 6 is equals to minus 3, X is equals to plus 3. Again, we will have CO plus 3, that is argon 18. This will be after plus 3, it will be 3d6. But here there will be no pairing. This is a weak ligand, right? So here we will see no pairing of electron. This is 1, 2, 3, 4, 5, and this is S and this is P, right? Okay, so no pairing means the electron 1, 2, 3, 4, 5, and this is 6. So here we will have, this is S, here we will have, this is S, this is P3. As we have 6 ligands attached to it, this means that can be either it has 6 ligands. Okay, in that case, guys, everybody, please understand this thing. If you have 4, then either you can have sp3 or you can have dsp2. Okay, this is tetrahedral, this is square planar, this is square planar. Now if you have 5, you can have just one, that is dsp3, that is trigonal bipyramidal. Now if you have 6, you can have octahedral, either you can have d2sp3 or you can have sp3d2. Both are octahedral. This is inner, this is outer. So here it will be outer complex, that is sp3d2. The other orbitals here, okay, the next orbital, that is next d orbitals, the 2 electrons it will occupy. The 2 electrons here, 1, 1, 1, 1, okay, sp3d2, okay, understood? So it will have outer sp3 configuration. So it will be sp3d2 configuration, okay, hybridization, sp3d2, that is outer hybridization. Understood, everyone? Perfect. Very nice. Very nice. Okay. In the tetrahedral complex like this, very important questions, very important nickel complex question. Okay. The hybrid orbitals are dash hybridized. Everybody in the chat box. There are few exceptions also. I'll tell you that if... don't worry, I'll teach you that also. Okay, in the tetrahedral complex, the hybrid orbitals are dash hybridized. What is this hybridized? What is the hybridization here? Okay, so we have firstly, let us see the oxidation number here. Everybody in the chat box, what is the oxidation number? Fast, bacha, very fast. X minus 4 is equals to minus 2. X is equals to plus 2. This is our practice session. This is a rapid fire round, okay? We are going to answer everything here. So guys, everybody, this is X plus 2. Okay, so nickel. Sakti, va, kar, man, fi, ko, ni. Ni means 28, okay? So ni means 28, okay? So Sakti, karman, fi, kuri, kajan. This is the 3D series, okay? So now this is 28, you have lost 2 electrons. This is argon, this is 4s2. It will lose 2 electrons from there. It will be 3d8, okay? This will be 3d8. Now you have 3d8 electrons here. We know that Cl is a weak ligand. This is a weak ligand. Okay, bacha? This is a weak ligand. So what will happen here? This is D and it will be 1, 2, 3, 4, 5. This is S. This is having 4 orbitals, right? Okay, very important. This is 1, 2, 3, 4, 5, 6, 7, 8. So the orbitals that are left here is, what are the orbitals? It's a weak ligand, okay? So what is the dipole moment? Okay, in that case they ask for dipole moment, or in some case they ask for dipole moment, is it? Is it in some case they ask for dipole moment? Okay. Nowhere they ask for dipole moment till now, right? Okay. So yeah. Where is this, guys? Okay. So this is sp3 hybridization. That means it has tetrahedral shape. Okay. This is sp3 hybridization. We'll write it as tetrahedral shape. This is S, this is P, this is 3. sp3, that means tetrahedral shape is there. Now someone will ask me, ma'am, why not octahedral? Because we have just 4 ligands, no? So either sp3 or dsp2, okay? So next we have the square planar complexes. The hybridization is involved is. What is the hybridization? Everybody, very nice. What is the hybridization involved here in square planar complexes? The hybridization is dsp2, okay? This is square planar hybridization having 4 ligands, okay? Next we have the magnetic properties of coordination compounds can be used to infer the, what can magnetic properties? The number of this in the metal complex is already answered, number of unpaired electrons, okay? Yes, okay. The complex, this is expected to have dash magnetic moment of dash unpaired electrons, okay? of a dash unpaired electron is expected to have a magnetic moment of what? What is the magnetic moment of this complex? Okay, everybody, what is the magnetic moment of this complex? Everybody in the chat box, what is the magnetic moment of this complex? I want all of you to answer this. What is the magnetic moment here, everybody? These are the always remember one thing. In coordination compounds, you have to do every single compound that is mentioned in your NCERT. Every single compound is important for you, and we have picked everything for you. NCERT line by line, all the compounds that are mentioned in your NCERT are here. So please do practice this. Do not waste your time. This is a very crucial stage of your career, very crucial stage of your NEET examination. Okay. So please be serious now. Okay. So the complex that is this. So we have x. This is minus. This is 5 is equals to minus 3. So it will be x is equals to plus 2. Okay. This is mn plus 2. Mn plus 2. Okay. We have mn plus 2. So we have mn plus 2 here. Mn is plus 2 here. Okay, everybody. Very nice, very happy, very nice. Shabash. Okay, very nice. So Mn2 positive, active carbon ficanogajan. So this is 25. This is argon 18. This is 4s2, 3d5. After losing 2 electrons, it will be 3d5 here. Okay, so it will have 5 unpaired electron. And the trick here is, you can also use this formula. 2 plus, this is n, that is 5. 5 plus 2. You can also calculate it like this. This is mu. Okay, you can also calculate it. But always the number of unpaired electron almost similar will be the magnetic moment. Okay, they have 5 unpaired electrons, similar magnetic moment. Just point difference will be there. Okay, so this is 5 point something Bohr magneton. Okay, understood? Okay, in the crystal field theory, wow, what an awesome theory. This is a very important theory. Crystal field theory, very important theory, very important theory we have. Okay, guys, so answer this question. I just want to tell you some exceptions here. Okay, I just want to tell you some exceptions here. One exception was there. Just note down this one thing here. Copper 2 positive. This is too bold. Copper 2 positive. Even if you have strong ligand, even then there will be no pairing. Okay, there will be no pairing of electrons even then if you have Cu2 positive. Okay, guys, this is the exception. Okay, perfect. Okay, so now let us do the crystal field theory here. So in this case, the crystal field theory, the degeneracy of d orbitals is lifted due to the degeneracy of this is lifted. What is the reason for degeneracy of dash of the ligands? Due to the interaction, right? Because see, this metal, okay, metal has two things. Metal is either it is vacant orbitals, it has electrons. So by electrons, it will have repulsions because there will be electrons of ligands as well. But if we have vacant orbital, there will be attraction. So because of these two forces acting on it, there will be breakage of the degeneracy. Okay, so the answer will be negative ligands. Okay, so the crystal field theory, degeneracy of d orbitals is lifted due to the negative of the ligand, the negative field of the ligand. What does that mean? The negative field of the ligand, the electron, the ligand will donate it and will degenerate, it will break the degeneracy of the metal atom. Okay, the d orbitals of metal atom. The splitting of d orbitals in octahedral field results in the set of. Okay, so how this is splitted? Everybody, the degeneracy is broken down. Okay, so we have this thing 1, 2, 3, 4, 5. So how it is broken down? It is broken down into two sets. Everybody in the chat box. Okay, it is broken down into two sets. What are these two sets? Okay, what is the meaning of this G here? This G means symmetry. G means symmetry. Okay, octahedral complexes are symmetrical complexes, and how they are distributed here? There's two things, 2 here, 3 here. Here we have dx square minus y square and dz square. This is xy, yz, zx. Okay, so okay, I'll just write it here. This is dx square minus y square. This is dz square. This is dxy. This is dyz, and this is dzx. Okay, so this is called T. This is called Eg. Okay, Yes. Understood, guys? Yes. G is for symmetry. In case of tetrahedral, there is no G. This is just T2 or E. Okay, just T2 or E. So splitting of the d orbitals in the octahedral field resulting in the set of dash energy T2G and a set of higher energy. Okay, lower, the set of lower, that is T2G, a set of higher, that is EG. Okay, the higher one is EG. The VBT suffers from the shortcoming of not giving quantitative interpretation of the dash data. The VBT is not able to give the quantity interpretation of what energies and all that, okay, of the magnetic movement, energies and all these things, okay. So dash considered the metal ligand bond to ionic arising purely for electrostatic interaction. The dash consists of metal ligand bond to be ionic. Which field considered this? Crystal field theory considered this as ionic bond, as electrostatic interactions. That is how this whole theory is made, okay. Perfect. In the VBT, everybody, I want all of you to answer this. Bacha, I want all of you to answer this. Yes. In the VBT, the assumption that the d orbital of the center metal atom are involved in bonding. Everybody answer this. Everybody, yes. In the VBT, the assumption the orbitals of center metal are involved in bonding does not explain dash of the coordination complex. It does not explain the color of the coordination. It means it does not explain the DD transitions. Okay, they're talking about the DD transition. Because of the degeneracy, there will be DD transition. There will be color. Okay, this will explain the magnetic character of some compounds. There will be strong field. Why this is a strong field? Why this is a weak field? Okay, everything will be explained by CFT, that is crystal field. VBT does not distinguish between dash and dash, that is weak and strong ligands. The dash orbital is of higher energy in an octahedral. They are saying the dash orbital is of higher energy in an octahedral crystal field due to greater repulsions from the ligands. Okay, so we have this ligand. So they are saying the dash orbital is of higher energy. Which orbital is of higher energy? The higher energy was of EG orbitals, right? That were dx square minus y square. Okay, what were these? Dx square minus y square and dz square orbitals. Next we have, according to magnetic susceptibility experiment, the compound this is dash because it contains no unpaired electrons. It contains no unpaired electrons. So what it wants to say, the compound of this has no unpaired electrons because here x will 0, there is no unpaired electron. Yes, okay, because of no unpaired electron, the magnetic susceptibility will be 0. Okay, this will be diamagnetic. Okay, where there is paramagnetic means it has unpaired electron. Diamagnetic means it does not have unpaired electron. Okay, so yeah, the energy separation in CFS is denoted by this for dash complexes. This one, what is this called? This is delta. This is CFS, crystal field splitting energy, crystal field stabilization energy for octahedral complexes. Okay guys, everybody, is it fine? Everybody. Okay. The octahedral complexes energy of 2 EG orbital increase by dash of delta O. The energies of 2 EG orbitals, okay, will increase by what of? Will increase by what? How many? What is a partition of that? This is like we have this O, these are this, and this is the barrier here. Okay, this is the barycenter. So here from here we will define the delta. This whole is delta O. What are these two differences they are talking about? This is 3 by 5. They are talking about the barycenter and this thing. Okay, the higher energy. This is 3 by 5. Okay guys? Yes. The other will be, yes, perfect. Okay. In the strong field, the pairing energy P is less. Very important question. In the strong field, the pairing energy P is less than crystal field splitting energy. This means pairing energy is less than crystal field splitting energy, resulting in dash spin configuration. Very important thing. Very important thing. Everybody. Yes, what is the answer? What is the answer to this? Dash is a low spin or high spin? Yes, This is low spin. I'll just tell you one thing. Just remember this thing always. For strong, this is strong. This is strong and this is weak, okay? This is weak. If we have strong, if we have weak. Now just remember this thing. This is strong ligand, this is weak ligand, okay? So here CFSC will be high. The splitting will be high, or we'll say gap between, means delta will be high, the gap will be high. It will be a low spin complex. It will be a low spin. It will be a high spin complex. Here the CFSC will be low. Here gap will be low. And here pairing will also be more. Here the pairing will also be more, okay? Here pairing will be less. Pairing will be less. Just always remember this thing. Always remember this thing. So many questions you will be able to solve by this thing only. Understood everyone? Right? Okay, perfect. Now next is ligands such as I negative and this are considered to be dash because they cause smaller splitting, as you all know. This is a weak field ligand. Why this is a weak field ligand? What is the reason behind a weak field ligand? The weak field ligand, what they do? Weak field ligand, what they do? The gap is less. The pairing energy is less. They cause smaller splitting, right? Okay, perfect. So these are called weak field because they cause smaller splitting. The gap is less. The CFSC energy is less. The pairing is less. Okay, understood? Yes. Now dash field ligands like this and this, so they are strong field ligands, produce the complexes that are more likely to exhibit low spin complex. Okay, low spin complex means strong field ligand they are talking about. In all these questions, you just need to remember this one chart and your thing is solved. Every question will be solved from this particular question, this particular chart. Every single question you will be able to solve this. Okay, now you have next, that is dash ligands, this and this, we have done this. Next we have for tetrahedral coordination entities, the crystal field splitting energies as compared to octahedral splitting. Okay, what they're talking about, what is this, what is the energy, what is the delta, what is the difference here? Okay everybody, what is the difference here? Everybody, what is the difference here? Strong. Okay, so for tetrahedral coordination entity, the crystal field splitting dash as compared to octahedral is splitting. Okay, so this is the tetrahedral they're talking. Yes, the tetrahedral is more than octahedral, right? And it is even more. The square planar is even more than that. Okay, so this is strong. This is splitting is dash as compared to. Okay, now they are talking about strong also. Tetrahedral is also strong, that is also right. So now they are talking about that above it will be 3, here it will be 2, right? Everything is inverted here. Here we will have dx square, dxy, dyz, this is dzx, and here we will have dx square minus y square dz square. Okay, this is because of the orientations of these two octahedral and tetrahedral species. Okay, the orientations of this, right? Okay, next we have this thing, that is in tetrahedral complexes, the delta T splitting for this is typically dash of delta O. What is the order? This is always more, okay? This is always more, right? This is always delta T is equals to 4 by, wait, this will be 4 by 9 of delta O, right? Four by 9 of delta O, right? Delta T. It will be this. Okay guys? Yes, very nice, very nice. So the complementary colors of the color generated from that leftover absorption by this is. Okay, this is talking about DD transition. It will give the complementary colors, right? The complementary color is the color generated from dash transitions. Okay, these are called DD transition of the wavelength of the light. For example, there's some wavelength, it will absorb that and will give the complementary color that we will see. Okay, the complementary color is always seen, right? If the complex absorb the light in blue-green region, the complementary color observed will be, okay, so it's very simple, Vib. Okay, so here you have blue-green, this is bluey-green, this is orangish color will be, orangish, reddish orange color will be observed here. Okay, so this is the observed color, this is the absorbed color, this is the complementary color here. Okay, so how I had written it, Vib, Gyor, Vibs. Okay, so bluish green, that means orangish red. Okay, so that means reddish color. Okay, so this is red color here. Red color will be given here. Crystal field splitting in tetrahedral coordination entities result in this is this orbitals being at dash, then this. Okay, of tetrahedral, these are on the higher level and this is on the lower level. This is called T2, this is called E. No G is here. G is for symmetry. Tetrahedral complexes do not have symmetry. Okay, so answer will be lower. Okay, orbitals being at lower than this. Okay, the crystal splitting in tetrahedral coordination entities results in this orbital being at lower. Tetrahedral complexes. Just give me a minute. Wait. Okay. What I have done here? Wait. Guys, just give me a minute. Complex, the energy of 2 Eg in this orbital. I think I have written opposite here also. Wait, the dash orbital is higher energy, right? Is an octahedral complex. This Eg is at the higher, is due to greater repulsion. Okay. Guys, just give me 2 minutes. This is at higher. So do they 2 Eg orbitals? But I am written here. Am I getting confused somewhere? Just wait. The tetrahedral coordination entity, the crystal field splitting of dash is also right. Wait, this is also right. Here we were right. The crystal field splitting of tetrahedral coordination complex of this orbital being at higher. So I should write higher only, right? Okay, this is wrong, right? Yeah. So it should be higher here, okay? So it should be higher, guys. Yeah. Okay. So now next we have the coordination. I'll write it here. Should be higher, not lower. It should be higher here. The coordination entity such as this is typically at spin complex. They are talking about the coordination entity. This is typically a dash spin complex. So we know that we have weak ligand here. In case of weak ligand, what kind of complex is there? In case of weak ligand, we have high spin complexes. Okay, we have high spin complexes in case of weak field ligands. Okay, the crystal field model is successful for explaining the color of coordination compound because it accounts for dash of the electrons upon the absorption. So he is saying the crystal field model, CFT model, explaining the color, that is by DD transition, because it accounts for dash of the electrons upon the light absorption. That means there is excitation. Okay, there is some excitation of electrons, like DD transitions are there. There is excitation of electrons, right? DD transitions. Okay. Next we have, according to CFT, the splitting of d orbitals in octahedral complexes such that T2G set is this more than that EG set. T2G set, this is the orbital in complex such as that in T2G set is dash, then this is lower than this. Okay, again this is T2G, this is EG, this is T2G, this is lower, this is higher. Okay. The G subscript is used for octahedral and square planar complexes which have center of symmetry. Yes, we have done this. Since dash complexes lack this, and this is not used. Which kind of complexes do not have G? These are tetrahedral complexes, do not have any G there. Okay. So the crystal field splitting diagram for octahedral field, that is this and this orbitals. Octahedral field, that means this they are talking about. Okay, this and this orbitals are placed dash the average energy of d orbitals in the spherical. Average energy is the barycenter here. Okay, they are higher than that. Okay, so above than that. Okay, or higher than that. Next we have, in the absence of ligand, CFT, crystal field splitting does not occur. The substances, in the absence of any ligand, the CFC does not, there is no though there is no ligand combination, right? The substance is a colorless, okay? There is no DD transitions, there is no ligand present there. No ligand is there, no DD transition is there, that will be totally colorless, okay? Even if it has no unpaired electron or it has no chance of DD transition, in that case also, it will be colorless. The crystal field splitting in tetrahedral field is this. Orbitals having in tetrahedral, we have this kind of thing. This is T2, this is E. Having dash energy compared to this. This is higher than energy. It has higher energy. So this has higher energy. Three are above and 2 are lower. So it has higher energy, right? Those synergic is what? Synergic is back bonding. Okay. So what happens here? This is metal. This is ligand. Ligand is donor, okay? So metal is like, okay, you are giving me electrons, but I have so many electrons, okay? So I have d orbital electrons. I'll give you back donation. I'll give you your electrons, okay? So it will give that electron, that is called back donation. That is called synergic bonding. In carbonyl complex, very, very important concept, very important, involves a donation of pair of electrons from filled orbitals of ligand to dash of metal. Okay, from filled orbitals of ligand to vacant of that. Okay, understood? So, everybody, yes, to the empty anti-bonding of the metals. Okay, guys. Now, next we have the metal carbon bond, and the metal carbonyl has sigma and pi character. So there are 3 types of bondings, right? So in that, synergic bonding is the most important bonding, and this is also very important for you, that this donates to anti-bonding pi star orbital. Anti-bonding pi star. This thing is very important. Now next we have the metal carbon, and metal carbonyl has just both sigma and pi character, where the pi bond results from dash donation of electrons. So we have metal carbon bonds. So this pi bond results from dash donation of electrons. Pi, we have sigma bond, we have pi bond. Okay, sigma bond is donation, the pi bond is back donation. Okay, so pi bond is the back donation here. Okay, understood everyone? This is the back donation. Okay guys, yes bacha, sigma bond is the back donation. Okay, firstly there will be donation, that is sigma donation, and the back donation will be the pi donation. This is the sigma donation, this is the pi donation. When it is going to give back the electrons, that is called back donation. Okay, when it is going to give back the electron, that is called back donation. So now next we have the hardness of water is estimated by simple titration with. The hardness of water is titrated against which coordination compound, which kind of compound, that is Na2EDTA. Very important application of coordination compounds, okay. In the complex, this the splitting of d orbitals is such that Eg level is dash than T2G level. So firstly we have weak orbitals, okay, this is weak. In case of weak ligands, we have high spin complexes, okay. The energy here is high. In case of weak, we have high spin complexes. Delta G is low. So, delta G is low, delta is low, delta is low, right? So, the splitting of D transistors such that Eg levels. So, this is octahedral level, right? This is octahedral species. This is octahedral. So, it will be 2 above, 3 below, right? So, Eg level will be above the T2G level. So, it will be above the T2G level. Okay, guys? Yes? Okay, perfect. Okay, guys, I'll do that. Just wait for just 10 questions left, okay? The ligands in the spectrochemical series are arranged in the order of increasing field strength. There's arrangement of spectrochemicals. I'll give you one trick about that. Okay, I'll make one trick on this. Just remind me in the comment section that ma'am, you have to make the trick on this particular series, spectrochemical series. Okay, the order of increasing field strength, where I negative being this is at the lowest level. Okay, it has very less splitting energy. Okay, there's this one order. You just need to learn that order. That's it. These are under the application of CFSE. Very important. Very important. Okay. So now we have the crystal field model has limitation and does not take account dash character of bonding between ligand and center metal atom. So we're talking about this thing. Everybody in the chat box. Everybody in the chat box. Yes. The crystal field model has limitation and does not take into account the dash character of bonding between ligand and centimeter repulsions. They are talking about the covalent kind of bonding was not taken in account. Ionic bonding was there. Okay, they just took one thing that is electrostatic interactions. So dash theory and molecular orbital theory go beyond CFT to explain the covalent character and other properties. Which theory have you read? What is that theory? It's called ligand field theory and molecular orbital theory. This ligand field theory is not in your syllabus, okay? Simply ligand field theory is not in your syllabus. This MOT is on your syllabus, okay? This is not in your syllabus. And MOT also not for these kind of complexes, okay? Understood? Yes. The color changes when adding the diene ligands. This is diene ligands, okay? We already learned about this. Are indicative of changes in dash environment around the nickel ion. The color changes of this complex when adding diene ligands are indicative. They indicate of changes in dash environment. We are adding the diene complexes. So there will be some change in the ligands, right? Okay. So this is changes in the ligands. Okay. Perfect. Perfect. Hemoglobin, the red pigment of the blood, you already know this, which acts as an oxygen carrying coordination compound. Very important, very easy. What is the oxidation compound here? Everybody. Very simple. For you, it's like the most simplest question here. The most simple question here. Okay. So here we have iron, right? Okay. Wait. Oh my God. Wait, what is written here? If I am right, this is written wrong, right? Okay. Hemoglobin, red pigment is of iron, not magnesium, is it? Yeah? This is wrong. Magnesium is in which kind of, this is chlorophyll? Is it chlorophyll? Yeah? Yes. Now tell me, this is not right, okay? This is not right. This is iron, okay? So now, hemoglobin has iron. What kind of the metal that is present there? What kind of compound is that in our natural system? Yes, that is chlorophyll. Very good. That is chlorophyll has magnesium. Very nice. Okay, very nice. Okay, the rhodium complex, that is this is Wilkinson. This is Wilkinson catalyst used for hydrogen. Very important catalyst. Okay. Wilkinson catalyst that is used for the hydrogenation of what? Very important complex, a Wilkinson catalyst that is used as the hydrogenation of what? Alkenes. Okay? Alkenes, we use Wilkinson catalyst, the rhodium complex. This, you just need to remember the formula of this Wilkinson catalyst. That's it. Okay? When di or polydentate ligand uses its lower or more donor atoms simultaneously to bind a single metal ion, it is said to be dash ligand. When di or polydentate ligand, we have, yes, perfect, we have di and polydentate ligand uses from two or more donor atoms simultaneously to bind single metal, it is said to be a dash ligand. What kind of ligand is that? Chelate ligand. What is chelate ligand? It forms ring, right? It forms ring. It leads to stability. It leads to stability by forming rings. For example, you have E3, right? You have coordination, CO, EN, 3 complex. You have this kind of complex. So it will form a complex like this. It will form a complex like this. It will form a complex like this. Okay. So this will lead to more stability as compared to cobalt CN6. It will be more stable as compared to this because this is a chelate. This is engagement ring. This is forming a ring. This is not an engagement ring. They want engagement ring now. They want engagement ring. They said, okay, ma'am, we want to get engaged and we want to make our life hell. So now, while writing the formulas of mononuclear coordination entities, there should be dash between ligands and metal with a coordination sphere. Mononuclear coordination entities, there should be dash of ligands, there should be no space between the ligands and metal of the coordination sphere. They are talking about no distance there, okay? When you are writing the name, you write it as diamine, okay? Diamine, then tri, aqua, okay? You write it like this, okay? So this is a no space between this, okay? There is no state, okay? Perfect. I think some the students here are getting married. They said we do not want brown ring, ma'am. We do not want brown ring complexes. We do not want these kind of rings. We do not want these kind of rings, ma'am. We want these kind of rings with a diamond on it, ma'am. We want that. They are saying that. They're saying, no, ma'am, we do not have any interest in rings of chemistry. We have interest in that ring, the diamond ring one. Okay, perfect. Write formulas of this is, we have done this. Okay, we are just left with 2 questions now. Just 2 questions are left now. Okay, everybody ready here? Okay. So, while naming the mononuclear coordination compounds, prefixes mono, di, tri are used to indicate the number of individual ligands. I have already done this, okay. When the names of the ligands include numerical prefixes, then the terms, what they are saying like ethylene diamine, okay. So, these kind of prefixes, now, you will always remember this. Because you are interested in engagement scenes, so you will be interested in this as well. This is bis, this is tris, this is tetrakis, okay? Your kind of name. Valentine is coming and you're getting these kind of names. See. Okay. Perfect. They have good expectations. Next we have bis, tris and tetrakis. In octahedral coordination entities of the type this, we have octahedral complexes of the type this. 3 donor atoms of the same ligands occupy adjacent position at the corner of octahedral face. We have dash isomer. Very important. You have 2 kinds of isomer. You have 2 kind of isomers. Everybody here. You have 2 kind of isomers. Everybody here. Yes. Gopika ma'am. Arey Gopika ma'am. Arey Baswa sir. Okay, now everybody tell me. NEET is my Valentine. Okay, NEET is my Valentine. Yes. NEET should be your Valentine this year at least. Only then you will get a Valentine next year. Otherwise, it will be very difficult for you to get that Valentine. When you will be in MBBS college, you will be like, yes, now I have a Valentine. Right? Okay. The Valentine, your Valentines will, run behind you after cracking NEET. So in octahedral coordination entities, we have 2 kind of things, okay? We have 2 kind of things. Now this is octahedral complex. Now, if we have this kind of geometry, if 3 similar complexes are joined here, okay? This is A, and this is also A. This is B, and this is B. These kind of things. Wait. And next we have this is A, and this is A, and this is A. So now tell me which is facial, which is meridional. This is A, this is A, this is B, this is B, this is B. Everybody tell me which is facial, which is meridional. They are saying we have 2 isomers, that is facial and meridional, okay? We have facial and meridional isomer. Now they are saying same ligands are on the adjacent positions. That is called facial. So here we have same kind of ligands on the adjacent position. For example, this one, and this one on the same adjacent position. This is called facial. Okay, not that will a facial, not this facial, this facial. Okay, so now this is meridional. Okay, this is meridional. This on the same plane. Okay, for example, this is octahedral. 1, 2, 3, 4 ligands here. 1 is above, 1 is below. So if you have same 3 ligands over here, here and here. That is called meridional. Now, if you have same ligands adjacent to each other, that is this one, and this one, that is called facial. Okay, there are two, facial and meridional. Okay, so next, last question that we have, that is in octahedral coordination entities of the type this, if the three donor atoms of the same ligands occupy position around the meridian of the octahedron, we get which isomer? They are talking about this one, this plane above, below, 1, 2, 3. Okay, so we have meridional isomerism. They are saying Mar, you should die. Okay, so now we have meridional isomerism. Okay guys, perfect. Everybody an aimless game. Don't worry, I'll teach you back bonding in detail. Okay, I'll teach you everything in detail. This is just for your practice. This is for your practice. This is for every single line of your NCERT. We are going to cover that chapter, but this is important for you. Why this is important for you? Because in inorganic chemistry, otherwise you have not only in inorganic chemistry, in physical, in organic chemistry. I'm not saying inorganic, I'm saying in organic chemistry, you have everything from your NCERT. So that is why NCERT becomes a very important thing for your practice. So that is why we are taking these sessions. Okay, so I hope so. Now, with this session, you are able to recall everything that you have learned in coordination chemistry. Your whole chapter is revised in that case, okay? This few questions, very, very important questions were here. Okay, everybody? Yes? After the seam, yes, bacha. The seam will be, they will combine the seam, okay? Backwards, the YouTube will combine the seam. So it will be available after 2-3 hours only. Okay, so the whole life, the physics, bio and chemistry, everything will be available to you. Okay guys, yes, in organic chemistry, So yes everybody, so we have completed coordination chemistry. So do let me in the comment section which chapter you want me to take through NCERT line by line next. Okay, which chapter do you want me to take? I want all of you to answer this. Okay, every one of you answer this, and I'll see where the majority goes. We'll pick that chapter. Okay guys, perfect. Okay beta, that is totally okay. I'll see which is this 85th. This is 85th, right? This is the crystal field splitting in tetrahedral results in dash. In tetrahedral you have 3 above, 2 below, right? So this is dxy, this is dxy, this is dyz, this is dzx, this is dx square minus y square, this is dz square. So this is higher, so we'll write it as higher energy than this. Okay, CFT. Okay, perfect. Yes. Okay, then bye-bye guys. Take care. Do write it in the comment section. All the very best and good night. Take care of yourself. Have a sound sleep. And yes, be ready for the game on. You have some new surprises coming in for you. So be ready for everything, okay? We just want all of you to study hard and we are always here for your help. Always here. So everybody, all the best. Bye-bye. Take care. Good night.